Right now, as you listen to this, something larger than anything we expected is moving through space. Not an asteroid, not a comet, not the predictable wanderers that our telescopes have catalogued for centuries. This object doesn't fit comfortably into the categories astronomy has spent generations refining. It is on a path that runs parallel to another visitor we already thought was extraordinary, the interstellar traveller 3I Atlas. Except this one, the bigger one, carries mass, scale, and behaviour that are forcing scientists to rewrite their models in real time. Two objects, both converging on Mars, their orbits intersecting the timelines of our observation. One slender, green-tinted, unmistakably interstellar. The other broader, heavier, more ambiguous. Together they are setting up an event that probability tables tell us shouldn't be happening. The situation is being monitored in quiet offices across NASA, ESA and private observatories, but it isn't being shouted from rooftops. The headlines will arrive later, maybe when it's safe, maybe when the data has settled into something conventional. But right now, the numbers suggest something uncanny. For the first time in recorded history, two cosmic bodies of completely different origins are threading through space toward the same planetary stage. Mars is about to find itself between a known interstellar wanderer and something far bigger, whose classification has already sparked arguments that won't resolve for years. This is where the scientific certainty begins to fray into speculation. The mathematics of orbits, the precision of trajectories, the chemistry of emissions, all of it gives us a framework. But when those numbers cluster in ways that probability says should take millions of years to arrange, we enter the uncomfortable territory where science has to acknowledge coincidence, while the human mind whispers about intent. Two objects on two different journeys, arriving within weeks, converging near the same planet. If this isn't coincidence, what is it? If this is simply chance, why does it look so much like choreography? The data arrived quietly, as it usually does. A faint blip on a survey telescope's nightly sweep. Analysts caught the drift, recalculated, and realised something was wrong. The orbital arc didn't fit the standard curves of long-period comets. It wasn't hyperbolic like 3I Atlas, yet it wasn't comfortably elliptical either. It looked like something had nudged it, something had altered the pathway. That discovery didn't trigger alarms, at least not officially. But emails began to circulate with subject lines stripped of emotion and body text that spoke volumes between numbers. And within hours, the conclusion was unavoidable. 3I Atlas is not the only thing heading for a rendezvous with Mars. There is something bigger following alongside, and its timing is almost impossibly precise. Stay with me on this late-night exploration as we trace the evidence and the speculation, as we consider what it means when the sky refuses to behave randomly, when probability and coincidence strain against the weight of observation. We are going to step carefully into the story of how two very different objects ended up racing to the same destination, how one became famous as the latest interstellar messenger, and how the other, larger companion, is forcing astronomers to wonder if what we're witnessing is just a fluke of orbital mechanics, or the kind of event that changes everything we thought we knew about what travels between the stars. The first part of this story begins with silence, because space offers no sound, only light, only photons gathered on detectors that translate the void into numbers. Those numbers told us about Atlas, the green-tinted traveller already carving its hyperbolic path toward the inner solar system. But the same detectors, in the same weeks, caught something else. A point of light where there shouldn't have been one, dim at first, then stubbornly persistent, moving in a way that resisted immediate classification. Analysts compared it to known catalogues, searched for orbital matches, but nothing fit. By the time the community began paying attention, the trajectory had been refined enough to reveal the truth. It was heading toward Mars, and it was big. Size is everything in astronomy. The faintest blip can sometimes represent a body larger than a city, while a bright glare might belong to a fragment smaller than a mountain. But in this case, the reflected light, the way it shifted as it moved. the shape of its coma forming under solar heating, all of it suggested something on a scale that dwarfed the interstellar traveller running beside it. Atlas, the slender green visitor, already fascinated scientists with its chemical anomalies and interstellar signature. Yet here was something heavier, slower in its brightening, building a presence in the sky that amateur astronomers could spot weeks earlier than they should have been able to. That discrepancy alone set off quiet debates. The opening act of this story isn't the sight of blazing tails or the brilliance of a comet streaking across the sky. It's the realization that probabilities are collapsing into patterns. Two objects, two trajectories, one red planet waiting at the crossroads. The calculations suggest that the larger body, whatever it is, will make its closest approach to Mars within days of Atlas's own flyby. That kind of timing is supposed to belong to fiction, not orbital mechanics. Yet here it is, laid out in the data feeds pouring into JPL and the European Southern Observatory. The theme emerges naturally, even before scientists are willing to say it out loud. This is about the limits of coincidence, about the razor-thin line between science explaining the improbable and human instinct, insisting that there is more here than chance. The sky is not empty tonight. It is crowded with meaning, and if the numbers are right, Mars is about to become the stage for something no one alive has ever witnessed. And so the story begins not with comfort, but with unease. Not with a quiet assurance that astronomy has everything under control, but with the kind of silence that follows the discovery of something too large to ignore, too strange to categorize, and too perfectly timed to dismiss. It is in that silence, in that tension between certainty and paranoia, that we now continue tracing two paths that shouldn't have met, racing together toward a planet that has always been our neighbour, but that may soon find itself caught between shadows far older and stranger than any we have prepared for. When astronomers first plotted the trajectories of the two objects, the diagrams looked almost like an error. Lines on a star chart rarely overlap so cleanly, especially when those lines represent bodies with different origins, different velocities, and different chemical fingerprints. Yet the projections told the same story again and again. Two distinct objects racing through space, their paths aligned toward Mars as though drawn by the same unseen hand. This wasn't a grazing alignment or a wide miss that could be shrugged off as coincidence. These were close encounters, the kind of overlapping windows that orbital mechanics usually scatters across centuries or millennia. And here they were, layered neatly within weeks, converging on the same point in the solar system. The first object, 3i Atlas, had already entered the astronomical conversation as another interstellar traveller, the third confirmed in human history. Its path was hyperbolic, a mathematical signature that guaranteed it was not gravitationally bound to the sun. Once it passed through, it would leave forever, vanishing back into the dark between stars. Its green coloration, driven by diatomic carbon and cyanogen emissions under solar radiation, gave it a visual character unlike the dim streaks of ordinary comets. Instruments picked up unusual chemical ratios, and its brightness curve defied some expectations. It was already a story big enough to keep the professional community and the amateur community buzzing with theories and counter-theories. But then came the second shadow. This second object appeared not as a whisper from interstellar space, but as a roar of data from the outer solar system. When telescopes caught it, its motion was subtle at first, but the calculations hardened quickly. Unlike Atlas, its trajectory wasn't clearly hyperbolic. At first it looked elliptical, suggesting a long-period comet from our own Oort cloud, but then the numbers bent in strange ways. Perturbations in the orbit hinted at something unusual, non-gravitational accelerations that couldn't easily be explained away by outgassing alone. And its size. That was what startled even the most cautious observers. Reflected light suggested a nucleus far larger than Atlas, possibly tens of kilometers across, maybe even more. Estimates fluctuated with every round of observations, but one thing became clear. Whatever this object was, it dwarfed the interstellar visitor beside it. By the time the data stabilised, the phrase bigger object had already entered the internal notes of observatories. That informal label spread quickly in the community, shorthand for a presence that seemed to demand more attention than even Atlas. Side by side, the two visitors became a paradox. One was fast, lean, and unmistakably interstellar. The other was slower, heavier, ambiguous in classification, and yet aligned in timing so tightly that it seemed impossible. Their shadows stretched across the same path, converging not on Earth, but on Mars. The red planet had suddenly become the gravitational meeting point for two bodies that should never have had anything to do with each other. The mathematics of orbital alignment tell us that bodies in space rarely cooperate. The solar system is too vast, the random ejections from other stars too scattered, the Oort cloud too chaotic. When you simulate the probabilities, you find that the odds of an interstellar traveller and a massive solar system body arriving at the same planetary neighbourhood within weeks are so vanishingly small that it should take millions of years for it to happen once. Yet here it was, unfolding in real time in 2025. That realisation spread like a chill through the research community. Probability wasn't supposed to look like choreography. Mars, for its part, orbited quietly as it always does, but it suddenly became the stage for a celestial drama that had no precedent. For decades, astronomers had predicted that interstellar visitors would pass by the Sun from time to time, but they imagined them as solitary wanderers, each one a rare gift of data before vanishing again. No one had anticipated that a local heavyweight would appear simultaneously, a larger, brighter object whose orbit aligned so closely with the visitors that it seemed less like chance and more like partnership. Instruments tried to keep up. Spectrographs broke down the light from both objects, separating emissions into lines and curves that could be compared molecule by molecule. The green of Atlas made sense, at least within the framework of exotic chemistry from other star systems. But the bigger object's spectrum puzzled researchers. Its emissions were familiar but off balance, like a song played in a slightly different key. Water vapour appeared, but not in the expected quantities. Carbon monoxide and carbon dioxide lines were stronger than models predicted. Trace metals shimmered in the data where none should have been so prominent. And the ratio shifted over time, as though the object's chemistry wasn't uniform but layered, revealing different personalities as it rotated and heated under the sun's growing influence. The two objects became nightly subjects for observatories scattered across the Earth. In Arizona, automated telescopes tracked their positions against the stars. In Chile, the VLT pulled spectral fingerprints from their light. In Hawaii, the Pan-STARRS survey refined orbital calculations to the 10th of an astronomical unit. Each night, the numbers confirmed what no one wanted to believe. The paths were converging on Mars. One would brush past the planet on October 3rd, the other just days later. A sequence that looked less like random astronomy and more like a scheduled appointment. This is where the human mind begins to tug against the data. Science says coincidence, because everything else would be too speculative. But the human brain says choreography, because patterns that meet are hard to dismiss. If two objects from unrelated origins can align so perfectly in time and space, then maybe we don't understand randomness as well as we think. Or maybe randomness isn't what governs everything we see. The conversation became hushed, coded in scientific language that preserved professional caution. But the undertones were there, bleeding through in phrases like unexpected correlation and unprecedented simultaneity. Words that meant something far stranger than their surface definitions. Observers on the ground reported their own unease. Amateur astronomers who had been tracking Atlas for weeks found themselves stunned by the bigger object's visibility. Through modest telescopes, Atlas appeared as a faint smudge, tinged green, delicate but distinctive. The larger companion, by contrast, blazed brighter, its coma swelling rapidly as it approached the sun. In binoculars, it was already spectacular, a broad tail unfurling across degrees of sky. Seeing them both in the same sky felt wrong, like watching two actors enter a stage that was only ever meant for one. Mars's robotic emissaries circling the planet in patient orbits became unwitting witnesses. The Mars Reconnaissance Orbiter, the Trace Gas Orbiter, even aging spacecraft still transmitting from decades-old missions. All would soon have their cameras and spectrometers turned toward the converging paths. Instruments designed to study Martian geology and atmosphere were being reprogrammed to catch glimpses of two shadows racing through space. For the first time, Mars was not just the subject of study. It was part of the experiment, caught in the middle of a convergence no one expected. The scientific community leaned into the data, refining, recalculating, adjusting parameters to account for outgassing, non-gravitational perturbations, and the subtle tugs of planetary gravity. But no matter how they sliced it, the conclusion remained the same. Two bodies, different in size and origin, were threading along parallel paths that intersected with Mars's orbit almost simultaneously. The weight of the discovery wasn't just in the science, it was in the atmosphere it created. Researchers found themselves working later into the night, staring at their screens long after fatigue had set in. Students whispered about the implications between classes, wondering aloud if coincidences this sharp ever really happen. Social media picked up fragments of the story, sometimes exaggerating, sometimes misrepresenting, but always amplifying the central tension. How could two shadows, so different and yet so aligned, travel the same path at the same time? The story was only beginning to unfold, and with each passing night the objects grew brighter, their approach more dramatic, their convergence more inevitable. The sky wasn't empty, not tonight, not for the foreseeable future. It carried two travellers, two mysteries, bound together by a mathematics that looked too clean to be accidental. And as Mars continued its steady orbit, unaware of the spectacle converging upon it, we found ourselves caught between the comfort of probability and the discomfort of patterns that looked too much like intent. The stage was set. Two shadows on the same path, racing through the void, carrying with them the questions that science struggled to answer and speculation refused to let go of. What they revealed, and what Mars would see first, remained ahead. The only certainty was that the sky itself had become a crowded place, and that our understanding of coincidence was about to be tested against the vast machinery of the cosmos. Astronomy rarely begins with certainty. It begins with pixels, faint blurs of light captured on sensors, translated into numbers that pass through layers of software before any human eye ever sees them. Every night, automated telescopes across the globe gather terabytes of data, most of it routine, most of it filled with predictable points of light that align with catalogues stretching back decades. But every once in a while there's a mismatch, a light that doesn't belong, a movement that defies the catalogue. Those are the whispers in the data stream, the anomalies that hint at something out of place in the vast machinery of the heavens. The story of these two converging visitors began in exactly that way. For Atlas, it was a survey telescope in Chile that first noticed the faint smear of light against the backdrop of Serpens Cauda, a single pixel that shifted when compared against the previous night's observations. Algorithms flagged it. Orbital solutions began to take shape, and the unmistakable hyperbolic trajectory soon marked it as interstellar. That was already unusual enough. Only two confirmed interstellar objects had ever been detected before. The fact that another had appeared so soon seemed improbable, but not impossible, a reminder that the galaxy is vast and filled with wanderers waiting to cross our view. But then came the second anomaly. The larger object appeared in data streams from multiple facilities almost simultaneously, like a chorus of whispers arriving from different directions. At first, analysts suspected errors, cosmic rays streaking across detectors, or ordinary comets temporarily hidden in solar glare. Yet the detections kept coming. Catalina in Arizona picked it up. Neowise confirmed it. Even amateur networks began to report faint brightening in the right coordinates. What was strange wasn't just the detection itself, but how quickly it solidified into something real. Orbital solutions normally wobble for weeks as more data refines the path. This one stabilized faster than expected, as though the object wanted to be seen. Inside control rooms, the tone shifted from routine to uneasy. Reports described brightness increasing at rates inconsistent with known models. Outgassing curves didn't match standard long-period comets. The object's photometric profile suggested something far larger than anticipated, possibly tens of kilometers across, maybe more, though estimates varied wildly depending on assumptions about reflectivity and dust production. In private notes, astronomers began referring to it simply as the bigger one, shorthand for something that didn't yet have a formal designation, but already dominated every conversation. Data streams do not speak in dramatic language. They arrive as tables, columns of numbers marking magnitude, right ascension, declination, error bars. To most people they look meaningless, but to the trained eye they whisper. A small shift in brightness here, a deviation in predicted position there, and suddenly you know you're not looking at an ordinary rock. What the streams whispered in September 2025 was that something unprecedented was happening. Two independent bodies, both rare in their own ways, converging on the same region of space at the same time. Atlas, the hyperbolic interstellar visitor, and the larger, ambiguous companion, its orbit bending in ways that suggested it was neither entirely foreign nor comfortably local. The whispers grew louder as spectroscopic data arrived. For Atlas, the signatures were already odd. Cyanogen lines too strong, iron lines conspicuously absent, nickel lines glowing bright where they shouldn't. For the bigger object, the whispers were subtler but no less troubling. Water vapour levels fluctuated erratically. Carbon monoxide spiked without clear correlation to distance from the sun. Trace metals appeared and disappeared as though the nucleus was a patchwork of unrelated materials. The data did not form a coherent picture, but it suggested an object with a complex and perhaps unnatural history. Some even speculated it might have been perturbed into its current trajectory by something more than gravity. Probability tables tried to anchor the conversation. Models of cometary flux through the inner solar system show that, on average, Earthbound surveys should detect a handful of new long-period comets each year. Interstellar detections are rarer, predicted once per decade at most. The chance of both occurring in the same season, aligned toward the same planet, approaches statistical zero. Yet statistics only describe what we expect, not what the universe is obliged to deliver. And so the whispers became louder still, not just in the numbers, but in the minds of those reading them. If the data pointed to impossibility, then perhaps our models were incomplete, or perhaps what we were seeing was not impossibility at all, but intention. Behind the walls of official agencies, the whispers became cautious memos. NASA circulated advisories noting unusual spectral properties. ESA flagged the convergence as of high scientific interest. Even the Minor Planet Center, usually the first to formalize designations with cold efficiency, delayed, as though reluctant to stamp a tidy label on something that refused to behave tidily. In the meantime, amateur astronomers filled the gap with names of their own. Some called the bigger one the Shadow of Atlas, others the Giant, others still the Second Voice. None were official, but each captured the sense that the sky was speaking in more than one register. Meanwhile, the instruments kept listening. The staccato tick of CCD shutters, the steady hum of servers processing petabytes of images, the rhythmic pulse of radio dishes tracking the faintest signals. Every sound in those labs was mechanical, yet the meaning felt almost organic, as though the universe was whispering secrets through the wires. The secrets weren't loud enough to be obvious, but they were insistent enough to keep scientists awake, staring at screens long after fatigue should have won. For those who dared to plot the trajectories together, the picture was stark. Atlas would sweep past Mars on October 3rd, coming within 30 million kilometres of the planet. The bigger object would follow just days later, closer still in orbital terms. 2 encounters, one after the other, both visible to spacecraft orbiting Mars, both passing through geometry so precise it could have been written into a script. If they had been discovered centuries apart, each would have been historic in its own right. That they arrived together made them something else entirely. The whispers in the data stream are not just about numbers, they're about patterns, the way lines converge on a chart, the way brightness curves rise when they shouldn't, the way emission spectra refuse to match expectations. For scientists, the job is to strip away the drama and focus on the numbers. But for anyone watching the streams closely, the drama was impossible to ignore. The sky was whispering in binary, in photon counts, in orbital parameters that aligned too neatly to be dismissed. Some researchers tried to push the narrative back into the realm of the ordinary. Perhaps the bigger object was just another Oort cloud comet, statistically unlikely but not impossible. Perhaps Atlas's hyperbolic trajectory was simply another reminder that interstellar wanderers pass through more often than we think, and we're only now catching them thanks to better surveys. Perhaps the convergence near Mars was just a fluke, the kind of alignment that probability grudgingly allows once every few million years. Those explanations were safe, and they made sense on paper, but they didn't quiet the whispers, because the data streams don't just whisper facts, they whisper tone. And the tone here was wrong. The numbers lined up too cleanly, the patterns were too sharp, the alignment was too precise. These were the kinds of signals that made even cautious scientists admit, if only privately, that coincidence might not be the whole story. The sky has always whispered to us, through telescopes and detectors, through spectra and curves, through the faint glimmer of light that travelled millions of years to reach us. Most of the time, the whispers tell us what we already know, that stars burn, that planets orbit, that comets shed tails as they dive toward the sun. But sometimes, as in the fall of 2025, the whispers say something else. They suggest that the universe is arranging pieces on a board we can barely see, pieces that move in ways we don't yet understand. 2 shadows, 2 voices, 1 data stream that refuses to fall silent. And so the scientists keep listening, the instruments keep watching, the numbers keep arriving, and in every row of data, every photon counted, every emission line captured, the same message lingers beneath the surface. Something larger is happening, something that probability cannot explain away. The whispers are still whispers, but they are growing louder, and soon, as Mars moves into position and the 2 visitors draw closer, those whispers may become something we can no longer ignore. The first object to capture the world's attention was the smaller of the 2, though calling it small is misleading. In the language of astronomy, size is relative, and what looks faint and fragile in the night sky can be a mountain of ice and dust spanning kilometres across. What distinguished this visitor wasn't its diameter, but its origin. It came not from the Oort cloud or the Kuiper belt, not from the frozen outskirts of our own solar system, but from beyond. Its trajectory carried the unmistakable mark of an interstellar wanderer. Hyperbolic, unbound. A visitor destined to enter and exit only once, leaving behind questions but never answers. It was labelled 3I Atlas, the 3rd interstellar object ever detected by human instruments. That alone made it historic. But its timing, its chemistry, and its proximity to Mars would make it something else entirely. The detection itself began quietly. July the 1st, 2025, the automated sweep of the Atlas Survey telescope in Chile flagged a faint smear of light that did not belong. At first, it was little more than a single pixel against a crowded star field, the kind of anomaly that often turns out to be nothing more than noise. But motion betrays truth. When compared to previous images, the point of light had shifted in a way that demanded attention. Orbital calculations followed, the kind that are repeated obsessively by analysts until confidence grows. The math revealed what the eyes could not yet see. This was no local comet, no periodic asteroid, but a traveller on a hyperbolic path, moving faster than the solar system's gravity could hold. The classification 3I was almost bureaucratic, the third interstellar object on record, following the much-debated 1I, Oumuamua in 2017, and the gas-rich 2I Borisov in 2019. But names cannot capture the unease that comes when another body from another star system passes through our own. We expect our comets to be family, their orbits long but bound, their returns inevitable. Interstellar objects are different. They carry with them the physics and chemistry of alien nurseries, the fingerprints of stars that are not our own. Every detection is not just an astronomical event, but a message in another dialect, a piece of material history written under conditions we can only imagine. Atlas carried that message in its spectrum. From the beginning, its green tint caught the eyes of those who looked through telescopes. To amateurs, it was simply beautiful, a smear of emerald light against the black. To professionals, it was troubling. The coloration came from diatomic carbon fluorescing under solar radiation, but the intensity and uniformity of the glow suggested concentrations higher than expected. Cyanogen emissions joined the mix, adding a toxic note to the spectrum, though in the vacuum of space toxicity is only a word. Together they painted a portrait of a body rich in volatile compounds, eager to display them long before water ice sublimation would normally dominate. The Very Large Telescope in Chile pointed its spectrographs toward the object and found something stranger still. Nickel lines, bright and unmistakable, but no iron. In the cosmos, nickel and iron are siblings, forged in the same stellar furnaces, scattered together in ratios as predictable as gravity itself. To find one without the other was like finding a sentence with words missing. Explanations formed quickly. Perhaps unusual chemistry in the parent system, perhaps space weathering that stripped away iron preferentially, perhaps some exotic reaction under the cold conditions of interstellar drift. Each explanation was possible, none was satisfying. The James Webb Space Telescope added its voice in August, peering into the infrared where molecules reveal their deepest secrets. It saw a composition dominated by carbon dioxide, far more than water vapour at distances where most comets are still quiet. That suggested layers, an onion-like structure where the outermost shells were built from volatile ices that activate early, long before the inner water-rich layers begin to contribute. Such layering told of a birthplace colder than the regions where our own comets formed, a nursery farther from its parent star, perhaps in the shadowed outskirts of an alien solar system. Every molecule was a clue, every ratio a fingerprint, and none of it matched perfectly with what we'd seen before. Observers on Earth began to watch as summer turned to autumn. Through modest backyard telescopes, the comet appeared as a faint smudge, its green coloration visible only to trained eyes. Larger instruments revealed a compact coma, a tail beginning to form, the hallmarks of a body warming under sunlight. It was not spectacular, not yet. But it was distinct, carrying an aura of otherness that made it stand apart from the familiar wanderers of our sky. The orbital path promised a close encounter not with Earth, but with Mars. On October 3rd, 2025, Atlas would sweep within 30 million kilometres of the red planet, close enough for spacecraft in orbit to turn their cameras and sensors toward it. For planetary scientists, this was an unprecedented gift. Mars, our neighbour, would become an observatory, offering a vantage point we could never achieve from Earth. The Trace Gas Orbiter, Mars Reconnaissance Orbiter, even aging missions like Mars Odyssey were prepared to pivot, to catch whatever glimpses they could of the alien traveller. The data would not just inform us about Atlas, but about the very process of interstellar visitation. As the date approached, tension built. Atlas was not alone. The bigger object, The one still being passed followed closely behind. But Atlas would arrive first, the opening act in a cosmic duet. It was the Scout, the smaller, stranger emissary whose chemistry already whispered of alien origins. The bigger one remained a looming question, but Atlas was here, measurable, analysable, ready to test the instruments of two worlds. The science was clear, but the speculation could not be silenced. Every anomaly invited interpretation. Nickel without iron became in some circles evidence of processing, as though the object had been refined. Carbon dioxide dominance suggested unnatural layering, as though someone had built it that way. The green glow, beautiful to the eye, became ominous in forums that spun it into signal, a beacon meant to be seen. Scientists pushed back, reminding anyone who would listen that exotic does not mean artificial, that natural chemistry is more diverse than our narrow samples suggest. Yet the whispers persisted, amplified by timing, by coincidence, by the uncanny choreography of two objects arriving together. In laboratories, the work continued methodically. Photons collected by telescopes were decomposed into spectra, orbital calculations refined with every new observation, production rates of gases modelled against solar flux, the numbers stacked into tables, the tables into papers, the papers into conferences. But beneath it all was a hum, a sense that Atlas was not just another data point but a messenger. Whether natural or not, it carried with it a story from beyond, a record of conditions in a star system far away, perhaps long gone. Every atom released into space was a syllable in that story, and every instrument listening was an interpreter straining to understand. Mars would hear the story first. Its orbit placed it in the perfect position, a witness closer than Earth could ever be. Cameras designed to study Martian dust storms would turn outward. Spectrometers built to examine methane would instead analyse cyanogen. Instruments designed for geology would measure the chemistry of a visitor from another sun. In that brief moment, Mars would cease to be just a planet. It would become a relay, a partner in our attempt to decipher the whispers of the interstellar. As the days ticked down to October 3rd, the comet brightened. Not dramatically, but steadily. Enough to remind anyone watching that it was alive in its own way, reacting to the heat of a star it had never seen before and would never see again. The tail lengthened, the coma swelled, the green glow deepened. Against the backdrop of Mars, it promised to be more than just an astronomical curiosity. It promised to be a spectacle, a convergence of science, chance, and wonder. And yet, even as Atlas approached, the shadow of the bigger object loomed. Everyone knew it was coming, larger, brighter, harder to classify. Atlas was the first, but not the only. It was the beginning of a sequence that probability said should not exist. The first note in a duet that mathematics could not comfortably explain. The first to arrive, yes, but not the last, and perhaps not the most important. Still, it carried with it the unique distinction of being interstellar, of being unbound, of being a true stranger passing through our system. Whatever followed, whatever explanations or speculations would come, Atlas would always be remembered as the one that came first. Its arrival was not an ending, but a beginning, a marker against which the second object would be measured. Side by side, they would force us to confront not just the limits of our science, but the limits of our imagination. For now, Atlas approached quietly, steadily, inevitably, its trajectory fixed, its chemistry glowing, its story written in light. And waiting just behind, the larger shadow prepared to follow, ensuring that this story would not end with one arrival, but continue into something far stranger. By the time Atlas was confirmed and catalogued, it already had a story, a framework scientists could begin to build around, a hyperbolic orbit, a chemistry that was peculiar but still quantifiable, a trajectory that left no doubt it was a true interstellar traveller, one of the rarest categories of visitor the solar system could host. There was something reassuring about that. The label of interstellar carried with it an explanation, however incomplete, and science works best when it can attach names and categories to the unknown. But when the second object appeared in the same data sets, there was no such comfort. It was larger, brighter, heavier, and it resisted the boxes that astronomers rely on. It became quickly known as the stranger of the two, and its presence complicated everything. Its first whispers had been dismissed. The Catalina Sky Survey in Arizona reported unusual points of light that seemed inconsistent with known bodies. Analysts tagged them as possible comets, but the motion didn't fit neatly. A few nights later, pan-stars in Hawaii confirmed similar anomalies. NEOWISE, looking in infrared, recorded unexpected heat signatures in the same region. At first, no one connected them to Atlas. The separation in the sky was enough to suggest coincidence. Only after orbital models began to converge did the truth emerge. Both objects were moving along paths that would bring them to Mars within weeks of one another. One was the known interstellar visitor. The other was something else, something harder to define. Size was the first shock. Photometric estimates suggested a nucleus tens of kilometers across, perhaps larger than 50 kilometers if its albedo was on the darker side. That would make it one of the largest cometary bodies ever observed entering the inner solar system. For context, Halley's Comet has a nucleus only about 11 kilometers wide. Comet Hale-Bopp, which dazzled the world in 1997, was roughly 60 kilometers. This new object, if early numbers held true, was in the same category as Hale-Bopp, or even larger, and unlike Hale-Bopp, it was arriving on a path that coincided almost uncannily with an interstellar traveller. Brightness rose faster than expected. Within weeks of detection, the object outshone Atlas by magnitudes, easily visible through small backyard telescopes and even faintly, with binoculars under dark skies. Its coma swelled to millions of kilometers, and tails began to unfurl not just one but several, fanning outward in complex structures that shifted night by night. Dust production rates seemed extreme, ejecting billions of kilograms per day under the growing influence of the sun. Models struggled to keep up, some suggesting jet-like outbursts, others hinting at fragmenting material. But the body itself, the solid nucleus deep inside, remained intact, looming larger with each recalculation. Its spectrum was the second shock, where Atlas presented as green. Dominated by diatomic carbon and cyanogen, this companion glowed with a more chaotic mix. Water vapour was present but inconsistent, sometimes strong, sometimes nearly absent. Carbon monoxide and carbon dioxide spiked in ways that didn't align with distance from the sun. Trace metals appeared, including magnesium and sodium, flaring at intensities that implied surface chemistry unlike anything in familiar comets. Even the dust reflected strangely, producing a reddish hue under certain filters that some instruments recorded as unusually polarized. The polarization suggested structured grains, aligned in ways that hinted at magnetic fields or unusual crystalline forms. Each dataset raised more questions than it answered. Orbit was the third shock. If it had been a long-period comet from the Oort cloud, its trajectory should have matched the elegant elliptical arcs that define such bodies. But this object's path wavered. Non-gravitational accelerations appeared in the models, deviations subtle but persistent, suggesting forces beyond simple solar heating. The outgassing jets could explain some of it, but the magnitude seemed too strong and the pattern too directional. Analysts adjusted parameters again and again, yet the solution never sat comfortably. Its orbit looked neither like a typical long-period comet, nor like a true interstellar hyperbola. It was caught in between, ambiguous, as though it had been nudged into its current trajectory by something unseen. The ambiguity fed speculation. Was this a body ejected from our own system long ago, wandering in the dark before being perturbed back in? Was it a captured interstellar fragment, slowed enough to masquerade as local? Or was it something more exotic still, a hybrid of natural and unnatural forces? Scientists kept their language cautious, but outside the official reports, debates raged in forums and late-night discussions. The timing alone was enough to drive paranoia. One interstellar visitor was improbable, but explicable. Two bodies arriving together, one clearly interstellar and the other resisting classification, was the kind of coincidence probability theory balked at. Even its visual presence reinforced the sense of strangeness. Where Atlas appeared as a neat green-tinged smear, elegant in its simplicity, the larger companion was unruly. Observers described it as a storm in the sky, a tangled mass of light and dust that shifted constantly. Images stacked over hours revealed structures curling and breaking, jets that fired in bursts, arcs of material that looked sculpted rather than random. Some amateur astronomers claimed to see filaments, strands of dust that resembled ropes stretching outward. Professionals cautioned against over-interpretation, blaming instrumental effects or atmospheric distortion, yet the reports continued, each one adding to the impression that this was not a normal comet. The Mars connection deepened the mystery. Projections showed that it would pass the planet just days after Atlas, even closer in orbital terms, a double flyby so improbable that models struggled to find a historical precedent. The red planet, long a focus of human curiosity, had suddenly become the centre of an astronomical convergence unlike anything we had recorded. Mars would not only see Atlas, but would almost immediately be visited by something far larger and stranger. Spacecraft orbiting the planet prepared for the event, their instruments recalibrated, their schedules rewritten. For a brief moment, Mars would become the best observatory in the solar system. Inside data centres, the numbers kept pouring in. Photons captured on CCD arrays, transformed into magnitudes, coordinates, and spectra. Every line of data added to the puzzle, every chart resisted final interpretation. The whispers became arguments, subtle at first, then louder, about whether the larger body represented something natural but rare or something entirely new. Terms like non-gravitational perturbation and anomalous dust polarization carried weight far beyond their technical meaning. They were ways of saying, without saying, that the universe might be showing us something we had not seen before. As September wore on, the bigger companion dominated conversation. Atlas was still the interstellar jewel, but it began to feel like the opening act. The main performance was looming behind, brighter, larger, more chaotic and harder to categorize. Its very ambiguity made it stranger. Natural bodies obey rules, even if the rules are complex. This one seemed to bend them, twist them, ignore them when convenient. Each new observation left scientists recalculating, students whispering, and amateurs staring through their telescopes with unease. The night sky has always been a canvas of prediction. We plot orbits, calculate returns, trace probabilities across centuries. But the arrival of two objects so different, so close in timing, shattered the illusion of control. The stranger companion refused to be ordinary, and its proximity to Atlas forced everyone to consider possibilities they would normally dismiss. Coincidence strained against imagination, and imagination pushed against science. For the first time in decades, the sky felt less like a predictable machine, and more like a stage where something unscripted was about to unfold. And so it moved closer, night by night, a storm of dust and light, a mass larger than Atlas and stranger in every measurable way. The second companion, the bigger presence, the body that made scientists hesitate before labelling, the one that looked less like chance and more like intention. It followed inevitably, and with it came the sense that Atlas had only been the introduction, and that the true story was about to arrive in its wake. Astronomy, at its core, is a science of numbers. Every discovery begins with them, every argument eventually rests upon them, and every mystery is measured by the stubborn refusal of numbers to say what we expect. Most of the time, they provide order. They show us orbits that repeat, cycles that can be trusted, constants that hold the fabric of space steady. But sometimes, numbers do the opposite. They reveal patterns that probability says should not exist. They align in ways that leave even the most cautious scientists unsettled. They whisper of order that looks too clean, too precise, too scripted. And in the autumn of 2025, the numbers describing two objects, Atlas and its larger, stranger companion, refused to behave like coincidence. At first, the calculations were routine. Orbital elements are derived from repeated observations, each data point tightening the curve of prediction. For Atlas, the process confirmed what everyone suspected. Its path was hyperbolic, carrying it in and then out of the solar system on a trajectory that could never be bound. Its inclination to the ecliptic measured at nearly 50 degrees, a steep tilt compared to most planets and asteroids, reinforcing its foreign nature. Its eccentricity, the measure of how far its orbit deviates from a perfect circle, was greater than 1.0, the mathematical fingerprint of an interstellar traveller. That alone would have been enough to make headlines. But then the second object entered the equations. Its orbital solution didn't settle so neatly. At first it appeared to be long period, with an eccentricity just shy of 1.0. That suggested an origin in the distant Oort cloud, one of the icy reservoirs at the edge of our system. But refinements pushed the eccentricity higher, closer to hyperbolic. Some models placed it above 1.0, others below, depending on which night's data were weighted most heavily. The inconsistency itself was alarming. Natural orbits are supposed to settle as data accumulates. This one wavered, never quite fitting comfortably into either category. To complicate matters further, non-gravitational accelerations appeared in the equations, tiny deviations in position that could only be explained by jets of material pushing the body off course. That was normal for comets, but the magnitude here seemed excessive. Too much deviation for the measured levels of outgassing. Numbers that should have matched did not, and corrections that should have smoothed the orbit only introduced new irregularities. Then came the timing. Atlas was projected to make its closest approach to Mars on October 3rd, passing within about 30 million kilometres of the planet. The larger object would follow just 9 days later, passing even closer. Two separate bodies, one interstellar and one ambiguous, both converging on the same planet within days. The probability of such an alignment was calculated again and again, each time with the same result, effectively zero, not low, not rare, zero, less than 1 in billions when modelled over the lifespan of the solar system, and yet here they were, marching together toward Mars like pieces on a board. The odds grew even stranger when analysts looked backward. Statistical reconstruction suggested that if either body had been perturbed by as little as 1 part in a million during its journey, the timing would have fallen apart. Atlas might have arrived decades earlier or later. The larger companion might have missed Mars entirely. But both, through millions of years of motion across light years of space, arrived within the same month. The numbers did not simply defy coincidence, they rejected it outright. In response, explanations multiplied. Some proposed that both objects were influenced by the same gravitational event far in the past, perhaps a stellar passage through the Oort cloud that dislodged multiple bodies simultaneously. Others suggested resonance effects, subtle gravitational harmonies with giant planets that had slowly sculpted their orbits into alignment. Still others whispered of more exotic causes, hidden masses beyond Neptune, even the long-debated Planet 9 tugging invisibly at the edges of the system. Each explanation was possible, none were clean, none erased the eerie neatness of the alignment. What made the numbers harder to dismiss was how they compounded with chemistry. Atlas displayed ratios of molecules that shouldn't exist without peculiar conditions, nickel lines glowing without iron. The bigger object displayed fluctuations in water vapour and carbon monoxide that didn't align with any model. Either anomaly would have been noteworthy. Together, arriving simultaneously, They created a data set that statistics alone could not dismiss. Probability theory is a cage we build around our expectations, but the universe seemed intent on breaking it open. Inside observatories, the mood shifted. No one wanted to say the word impossible, but everyone felt it pressing at the edges of their conversations. Graduate students muttered about choreographed motion. Senior scientists fell silent in meetings when the numbers lined up too cleanly. The Minor Planet Center, normally swift to assign designations, delayed for weeks before formalizing the larger companion. The hesitation was telling. When numbers point to impossibility, even bureaucracies pause. Amateurs, meanwhile, watched with awe. Through their telescopes, they could see Atlas glowing faintly green, a smudge of light that spoke of alien origins. And nearby, brighter and broader, the larger object swelled each night, its tails shifting like banners in the solar wind. To them, the numbers didn't matter. What mattered was the feeling that something rare was unfolding above them, something they would tell stories about for the rest of their lives. But even amateurs could sense the strangeness. They knew comets, and they knew this was different. Two bodies so close in timing was not normal, and though they lacked the equations, they could feel the same unease that the professionals wrestled with. The scientific process demanded restraint. Papers spoke of unexpected simultaneity, of statistically unusual alignment, of anomalous orbital solutions. But stripped of academic phrasing, the truth was simpler. Numbers were refusing to behave. They were pointing to a convergence that mathematics said should never happen. They were suggesting that randomness was not the whole story. And once numbers reach that point, speculation takes over. Some whispered about directed motion, the idea that one or both bodies had been nudged deliberately, not by gravity but by something else, not a popular theory, but not unheard of. Others pointed out that coincidences do happen, even improbable ones, and that our minds are wired to see patterns where none exist. Yet neither camp could silence the feeling that lingered in the data, a feeling that Mars was about to become the centre of a story larger than coincidence could explain. The days moved forward. Orbital refinements continued, each iteration confirming the impossible timing. Spectral data poured in, confirming the chemical anomalies. Photometric curves were tracked, showing brightness increases out of step with distance. And through it all, the numbers refused to bend. They refused to give scientists an easy out. Instead, they demanded to be taken seriously, to be accepted as they were, evidence of something improbable unfolding in real time. When numbers refuse coincidence, they force us into uncomfortable territory. They make us confront the limits of probability, the fragility of our models, and the possibility that the universe is not as random as we like to believe. In the case of Atlas and its companion, they forced us to watch as Mars became the focal point of an event that defied statistics, that looked less like chance and more like choreography, and that hinted at patterns we were not yet ready to name. And so, the story continued, with two objects racing together through the void, their paths converging in defiance of probability, their chemistry mocking our models, their timing daring us to believe in coincidence. The numbers kept whispering the same message, over and over, in the language of mathematics that has no agenda, no imagination, only truth. And that truth was simple. What was happening in the sky above us should not be happening at all. Mars has always lived under our watchful eye. For centuries it was the wandering star that kindled curiosity, its reddish light cutting across the constellations with a steadiness that made it both familiar and strange. Through telescopes, it became the world of canals, the imagined realm of civilizations, the mirror where we projected our hopes and fears. Through spacecraft, it became a laboratory, its valleys and volcanoes charted, its dust measured, its thin air tested. We have sent more machines to Mars than to any other planet, not because it is the closest, but because it feels like a neighbour whose silence we have never fully accepted. In the autumn of 2025, Mars found itself caught in a story not of its making. Two objects, two bodies on impossible converging trajectories, were threading their paths past the planet in a sequence so unlikely that probability theory broke down under the weight of it. Mars, orbiting as it always had, became the centre of geometry, the fulcrum where two cosmic visitors aligned in their timing. To Earth, they were mysteries unfolding in the night sky. To Mars, they were approaching realities, looming presences that would sweep past in the span of days. The first, Atlas, would arrive on October 3rd, passing at a distance of about 30 million kilometres. To human eyes, that is far. To astronomers, it is intimate. The second, the larger and stranger companion, would follow just 9 days later on October 12th, its closest approach even tighter in orbital terms. Mars would stand between them, a silent witness to the passage of two objects that had no business arriving together. The planet, with its canyons and craters, its storms of dust, its ancient riverbeds long since dry, had suddenly become the meeting ground of forces from beyond. The irony was not lost on anyone. For decades, we have looked to Mars for answers about life. We have searched for fossilized microbes in its rocks, for traces of methane in its atmosphere, for clues about its wetter past. Yet now Mars was not the object of our search, but the object in the middle, the stage upon which two unrelated visitors would perform. The red planet, long considered the target of exploration, was about to become a vantage point, a place where cameras not meant for deep space would catch the flicker of alien bodies racing by. The spacecraft already in orbit around Mars became crucial. The Mars Reconnaissance Orbiter, operating since 2006, had its high-rise camera calibrated for Martian surface geology, but controllers began preparing it for long exposures aimed outward. The Trace Gas Orbiter, designed to study the thin air for chemical hints of methane, would turn its spectrometers toward Atlas and its companion, hoping to analyse emissions from hundreds of millions of kilometres away. Even MAVEN, orbiting since 2014, was tasked with adjusting its ultraviolet sensors. Instruments that had spent years focused inward would now look outward, repurposed in a way no mission planners could have anticipated. For the scientists behind those missions, the opportunity was staggering. Earth telescopes could only do so much. Mars offered a second perspective, a parallax that sharpened orbital models and extended the reach of instruments. From Earth, Atlas looked like a dim emerald smear. From Mars, it would blaze brighter, its proximity amplifying every detail. The larger companion, with its chaotic tails and anomalous chemistry, would dominate the Martian sky. For a few days in October, the red planet would have two additional suns of sorts, though faint and ghostly, trailing dust and gas as they swept past. The numbers showed something else as well. Mars itself would feel subtle effects. The passing bodies would not crash into the planet, nor would their tails sweep across its surface. But their presence would leave traces. The solar wind, already turbulent near Mars's weak magnetic field, would be disturbed by the expanding coma of the objects. Charged particles would ripple across the tenuous Martian atmosphere. Instruments on MAVEN predicted temporary fluctuations, localized auroras dancing where none should normally appear. In a planet so often silent, even whispers of such events carried weight. The geometry was uncanny. Drawn on a star chart, the two orbits seemed like threads converging on Mars, crossing just as the planet arrived at the intersection. A week earlier or later, the alignments would have missed. A small shift in eccentricity or inclination, and the convergence would never have happened. Yet here it was, unfolding with clockwork precision. Mars was not chosen. It was not targeted. And yet it stood directly between the paths, as though waiting. Numbers insisted this was coincidence. Instinct argued otherwise. For those on Earth following the story, Mars took on a new kind of role. It was no longer just the rusty world we dream of colonizing, or the barren desert we probe with rovers. It became a witness, a bystander pulled into a story larger than itself. The idea that Mars, of all places, would host the simultaneous flybys of two such unusual visitors gave the planet a symbolic weight it had not carried since the days of Percival Lowell's canals. Suddenly people spoke of Mars not as a dead world, but as a stage, a crossroads, a planet cast in the role of middle ground between mysteries. The public fascination grew, fueled by images trickling out from amateur telescopes. Social media filled with side-by-side photographs. Atlas, faint but green, the larger companion, brighter and unruly. They were distant, yes, but they were real. And the fact that Mars sat squarely between them added to the sense of drama. Even those who cared little for astronomy felt it, the sense that something unusual, something that didn't belong to the ordinary rhythms of the sky, was unfolding. Among scientists, the conversation was more cautious, but no less charged. Meetings filled with talk of orbital dynamics, of perturbations, of resonance. Mars was discussed not only as an observational outpost but as a test of models. Would its gravity nudge either visitor enough to shift their paths? Could its thin atmosphere capture dust from the Comet? Would the passing objects alter the charged environment around the planet in ways our instruments could catch? Every possibility was modelled, simulated, debated. The answers varied, but the excitement did not. Mars was about to experience something no other planet had in recorded history. And yet, beneath the calculations, there was unease. The timing was too neat. Atlas arriving first, the larger companion following. Both aligned with Mars, not Earth, not Jupiter, not Venus. Why here? Why now? Probability dismissed the question as meaningless, but human curiosity lingered. For generations, Mars has been our mirror. Now it was a mirror of something stranger, caught between two visitors that probability insisted should never have arrived together. As the calendar turned closer to October, anticipation thickened. Every night the objects grew brighter, their coma swelling, their tails stretching further into the darkness. Mars, visible in the same sky, shone faintly red, a reminder that it was waiting at the crossroads. In classrooms, students asked their teachers why two comets were passing Mars at once. In laboratories, graduate students stayed late, tweaking models to account for non-gravitational forces. In observatories, astronomers spoke in cautious tones about alignments that looked less like chance and more like choreography. The red planet remained silent. It spun as it always had, its dust storms churning, its canyons stretching from horizon to horizon. But in the language of numbers, in the diagrams of orbits, in the glow of two objects racing closer, Mars had become something new. It was no longer just a planet. It was between coincidence and conspiracy, between natural and unnatural, between two bodies that refused to be dismissed. It was the centre of a geometry that probability could not explain. And soon, it would be more than geometry. Soon, Mars would be the closest witness, the planet against which the shadows of two visitors would pass. The story was no longer just about trajectories or chemistry. It was about place, and Mars, silent for eons, had become the place where impossibility converged. Size in astronomy is never simple. What the eye sees through a telescope is almost always deceptive, a blur of light distorted by atmosphere, a coma of dust that disguises the solid nucleus deep inside. Brightness can mislead, because reflectivity varies wildly. A small reflective object can shine as brilliantly as a much larger one cloaked in dark material. So when scientists first tried to measure the bigger visitor, they argued, recalculated, and disagreed, because the numbers did not want to settle. Yet as the weeks wore on, as more instruments turned toward it, the truth began to emerge. This was not a modest body. It was not comparable to Atlas in scale. It was larger by orders of magnitude, a presence that dwarfed its companion and demanded attention not just for its trajectory, but for its sheer physical dominance. The first reliable photometric curves came from pan-stars, stacking multiple nights of images to reduce noise. They suggested a nucleus tens of kilometers wide, at least 40, possibly 60 or more. If the albedo was low, as most comets are, then the numbers edged higher still, hinting at 80 kilometers. That placed it among the giants of cometary history. Few such bodies are known. Hale-Bopp, which blazed across the skies in the late 1990s, had been estimated near 60. The larger companion now approaching Mars seemed at least comparable, if not greater. For an object that had appeared without warning, it was staggering. The James Webb Space Telescope added infrared observations, measuring thermal emissions that revealed how much heat the body absorbed and re-radiated. Those numbers confirmed the scale. It was massive, far larger than Atlas, with surface area sufficient to release torrents of gas and dust under solar heating. And indeed it did. Within weeks, its coma swelled to millions of kilometers across, enveloping the nucleus in a haze so vast it could have swallowed planets whole. The tails multiplied, branching into complex structures that shifted nightly, signs of immense activity. Amateurs could see it easily with binoculars. Professionals watched in awe as the object brightened at a rate no one had predicted. Its dust production alone was enough to unsettle models. Estimates placed it at billions of kilograms per day, material streaming into space at velocities of hundreds of meters per second. That much dust reshaped the environment around it, interacting with the solar wind, bending magnetic fields, creating ripples that spread outward like invisible waves. Instruments measuring polarization of the dust noticed patterns too orderly for chance. Grains aligned as though sculpted by forces beyond mere sunlight. The brightness curves rose not smoothly but in pulses, suggesting jets firing in sequence, as though the body rotated and expelled material in measured bursts. Scale was not just about size. It was about power, about the ability of one object to dominate its surroundings, and this visitor did so absolutely. From Earth, it was now outshining Atlas easily. The green smudge of the interstellar traveller remained fascinating, but it seemed fragile beside the sprawling storm of the larger companion. Through telescopes, Atlas was a curiosity, while the bigger object was a spectacle. Even observers unfamiliar with orbital mechanics could sense the imbalance. One was delicate, unusual, a visitor from afar. The other was overwhelming, chaotic, and yet strangely deliberate in its behaviour. Together they created a contrast that magnified the strangeness of their timing. As its coma expanded, scientists debated what this scale meant. If the nucleus was truly among the largest ever recorded, then it carried implications about its origin. Bodies of such size are rare in the Oort cloud. Most are fragments, small shards from collisions or ejections. To find one this intact suggested it had been preserved for billions of years, untouched until some gravitational nudge dislodged it. If it was interstellar, as some argued, then its preservation was even more remarkable. To survive the interstellar medium intact for millions of years, still volatile, still active, was nearly unthinkable. And if it was neither, if its trajectory was too ambiguous to fit either box, then the mystery deepened. Size alone demanded explanation. Mars, caught between the paths, would see that scale more clearly than Earth. Models predicted that when the larger object made its closest approach, its coma would span a volume larger than the planet itself, visible from the Martian surface as a diffuse glow stretching across the sky. Rovers, if their cameras could be turned outward, might have caught faint smears of light, though no mission was designed for such a spectacle. Orbiters, however, were ready. The possibility of watching a planetary sky lit by the passage of a colossal body was unprecedented. For Mars, it would be a brush with grandeur, a reminder that even a planet can seem small when measured against the giants of the solar system's debris. On Earth, the fascination turned into unease. News outlets, cautious at first, began to report on the scale of the object. Terms like mega comet and giant interloper entered headlines. Comparisons to Hale-Bopp and Halley stirred memories of past spectacles, but this was different. This was arriving alongside Atlas, an interstellar body, with timing that defied probability. Public imagination turned restless. Forums filled with speculation, from theories of hidden planets to whispers of intent. Scientists tried to temper the conversation, reminding everyone that size does not imply threat, that its trajectory was not aimed at Earth, that Mars would be its stage. But the numbers told their own story, and numbers rarely calm unease. The bigger visitor did not just reveal its scale through brightness and dust, it revealed it through its influence. Non-gravitational accelerations continue to appear in orbital models, larger than expected for any known comet. The object seemed to resist prediction, shifting slightly off its projected path, as though something within was propelling it. Jets were the safe explanation, but even the strongest cometary jets known could not account for the magnitude of deviation observed. This was scale not just in physical dimensions, but in behaviour, a scale of anomaly that forced modelers to admit their equations were insufficient. Its tails grew stranger too. One was broad and diffuse, the typical dust tail pushed by solar radiation. Another was narrow and straight, the ion tail aligned with the solar wind. But then came others, fainter, curling in arcs that no model could easily explain. Some nights they appeared as wisps. Other nights they sharpened into threads stretching across degrees of sky. Observers debated whether they were real or artifacts of imaging, but multiple instruments confirmed them. A giant body producing tails in patterns that looked less like randomness and more like design. Scale became not just a number, but a presence. Atlas had been the first, delicate, green, scientifically profound. The bigger visitor, however, dominated the narrative by sheer force. It was the storm to Atlas's whisper, the giant beside the traveller. Together they should not have existed in the same sky, not in the same month, not on paths converging so closely. Yet here they were, and the larger one was making sure no one could ignore it. Mars was waiting, turning on its axis, moving steadily in its orbit, unaware of the spectacle approaching. For the planet, scale was irrelevant. For us, it was everything. We measured it in kilometres, in kilograms, in magnitudes, in deviations, in tails stretching across the heavens. We struggled to fit it into our categories, into the boxes of comet or interstellar, local or foreign. But each measurement, each recalculation, only confirmed the same truth. This was something larger than we expected, stranger than we had prepared for, and louder in its presence than any natural body had the right to be. And as it revealed its scale night after night, the question shifted from what it was to why it was here. Size alone could not explain the timing, the coincidence, the choreography of its arrival alongside Atlas. Numbers described it, but they did not answer it. And so the bigger visitor kept growing in our imagination, as much as in the sky, a shadow too large to dismiss, a presence that turned coincidence into conspiracy simply by existing where it did, when it did, on the scale that it did. When astronomers describe a comet, they usually speak in muted terms. White for the dust, faint blue for the ion tail, sometimes a soft green glow when carbon molecules are excited by sunlight. These are the predictable palettes of icy wanderers, colours that have repeated so often in the sky that they feel almost routine. But as the bigger visitor drew closer to Mars, and as more telescopes captured its light, something new began to appear. The colours did not match the categories. They shifted, shimmered, and split in ways that should not have been possible. It was not simply brighter than Atlas. It was stranger. Its spectrum filled with notes that no comet had ever played before. The first hints came from amateur astronomers stacking images from backyard telescopes. Some reported a reddish tint in the dust tail, far deeper than the faint yellows usually seen in scattered light. Others noticed flashes of turquoise where no filters should have produced them. At first, these reports were dismissed as camera artifacts, the result of uncalibrated sensors or atmospheric distortion. But when the same hues began to appear in professional datasets, the dismissals faded. The object was producing colours that defied the expectations of cometary chemistry. The European Southern Observatory confirmed it first. Using the Very Large Telescope spectrographs, scientists decomposed the light and found anomalous peaks. A strong emission line appeared near 357 nanometers, the familiar green of diatomic carbon, but alongside it were lines in regions rarely associated with comets. Around 720 nanometers, a deep crimson glow spiked, stronger than any sodium or iron line could explain. At 420 nanometers, a faint but persistent violet emission pulsed. The spectrum did not form the tidy profile of a normal comet. It looked more like a chorus, with multiple instruments playing at once, some familiar, some alien. The James Webb Space Telescope, sensitive to infrared, added another layer. It recorded unusual absorption features that hinted at exotic ices, perhaps nitrogen-rich compounds that rarely survive intact in the solar system. But one feature in particular caught attention, a broad reflection band that gave the dust a polarized glow. When analyzed, it suggested crystals aligned in structures too orderly for randomness, reflecting light in shifting hues depending on angle. To ground-based observers, this meant the comet's colors seemed to change subtly from night to night, from telescope to telescope. It was as if the visitor carried with it a dynamic palette, an atmosphere of hues that could not be pinned down. Colors, in astronomy, are supposed to be signatures. They tell us about composition. Green means carbon, blue means ions, yellow means sodium. But here, the colours did not align cleanly with chemistry. The red was too strong, the violet too persistent, the turquoise flashes too localised. Some speculated that complex organics, tholins, were responsible, molecules forged under cosmic radiation in the outer reaches of space. Tholins can produce deep reds and purples, staining surfaces like those on Titan. But even that explanation faltered. The intensity of the emissions was too high. The variations were too rapid. This was not just surface coloration. This was something active, dynamic, alive in a way normal cometary chemistry was not. Mars, waiting between the two objects, would see the colours more vividly than Earth. Projection suggested that when the bigger visitor reached its closest approach, its coma would span tens of millions of kilometres, large enough to dominate the Martian sky. Instruments on orbiters were recalibrated to detect the anomalous emissions. The trace gas orbiter, designed to sniff out methane, was tasked with looking for nitrogen-based compounds. HiRISE, meant for high-resolution imaging of the Martian surface, prepared to capture long exposures of shifting hues above the horizon. For a planet so long associated with red, the irony was sharp. Mars, the red planet, would soon be lit by colours it had never known. Back on Earth, speculation spread faster than the data. Images circulating online showed composites that exaggerated the hues, painting the visitor as a rainbow in the night. But even unprocessed images revealed something unusual. The crimson tail, faint but real, extended like a wound across the sky. The violet halo around the coma gave it an eerie aura. The turquoise flashes captured in stacked frames looked like signals, flickering with a rhythm that begged interpretation. Scientists urged caution, reminding the public that exotic chemistry does not mean intelligence, that colours are the natural result of light interacting with matter. But the disclaimers felt thin against the spectacle of hues that had no precedent. The unease deepened when the colours changed. Over successive nights, observers reported shifts in dominance. One evening, the crimson tail glowed brightest, saturating filters meant for other wavelengths. The next, the turquoise flashes flared stronger, overwhelming detectors calibrated for faint signals. The violet halo thickened, then thinned, then returned. The object seemed to wear different cloaks each night, as though it was not a single chemical process but a rotating gallery of reactions. Some linked the changes to rotation, suggesting the nucleus was heterogeneous, with patches of exotic material exposed in sequence. Others wondered if solar interactions were sparking complex cascades of reactions. Neither explanation felt complete. Colours are meant to be stable. Even in variable stars, the hues shift predictably with temperature. Even in auroras, the greens and reds arise from well-understood atomic emissions. But here, stability was absent. Instead, there was variability without rhythm, unpredictability without cause. It gave the impression of intent, though intent was the last thing science was willing to consider. The human mind, however, could not help but wonder. When light flickers in hues that have no category, it feels less like chemistry and more like communication. For the public, the colours became the defining feature. Atlas, with its elegant green, remained the interstellar jewel. But the larger companion was the spectacle, the one people asked about in headlines, the one that filled photographs with strange hues. It became known informally as the Painted Comet, though no official name had been assigned. Others called it the prism, the torch, even the signal. None of these were accurate, but each carried the same sense, that this was not just another comet. It was something else, something that spoke in colours we did not expect. Within the data, scientists searched desperately for order. They plotted emission lines night after night, hoping for patterns. They compared ratios of intensities, hoping for correlations with solar activity. They modelled exotic ices, hoping to reproduce the spectra in simulations. Progress came slowly. Nothing matched perfectly. Some features remained unexplained entirely. The crimson emission resisted classification, sitting awkwardly between known lines. The turquoise flashes refused to align with expected molecules. The violet halo suggested ionization processes beyond standard cometary physics. Each colour was a puzzle, and together they formed a mosaic that science had no language for. As October approached and the objects neared Mars, the urgency grew. The closer they came, the more visible the colours became, and the harder it was to dismiss them as artefacts. Amateurs continued to stack images, producing composites that looked surreal, but were backed by real photons. Professionals tightened their error bars, confirming that what they saw was not imagination but reality. The bigger visitor had revealed not only its scale but its strangeness, and the colours were the loudest proof. In astronomy, strangeness is both gift and burden. It offers discovery, the chance to see something never before recorded. But it also unsettles, breaking models, forcing recalculations, leaving gaps in knowledge that feel uncomfortably wide. The colours of the bigger visitor were precisely that, a gift of mystery, a burden of explanation. They did not fit. They refused to settle. They shifted and changed and pulsed as if mocking our attempt to pin them down. And in that refusal they became more than just light. They became questions. Questions that Mars would see first, that our instruments would struggle to answer, that our imaginations would not let rest. The sky is supposed to be predictable. Comets are supposed to be pale, faint, simple. But here was a body that painted itself in hues that shouldn't exist, a palette no comet had ever carried, a spectacle that left even the most rational observers feeling as though the universe was trying to tell us something. The bigger visitor did not simply reveal its colours, it revealed our limits, the point at which science strains to keep up and wonder begins to take over. When astronomers calculate the properties of a comet or asteroid, they usually begin with assumptions that hold true across hundreds of examples. Brightness, when combined with distance and reflectivity, gives a rough estimate of size. Dust production rates suggest surface activity. Outgassing curves reveal mass loss over time. With enough observations, these numbers stabilise, forming a picture that allows scientists to compare the new object with those already catalogued. The The models are robust, tested against decades of data, refined by spacecraft flybys, grounded in physics. But the bigger visitor approaching Mars refused to fit. Each time its mass was estimated, the result contradicted the model, forcing recalculations that never converged. It became the body that defied quantification, a reminder that not all visitors obey the rules written for them. The first signs came when brightness suggested a nucleus on the scale of 60 to 80 kilometers across. That alone placed it among the giants, a size that carried enormous implications for its mass. Assuming a typical density for cometary material, roughly half that of water ice, or about 0.5 grams per cubic centimetre, the object's total mass should have been on the order of 10 quadrillion tons. That number was staggering but manageable, within the range of what physics could handle. But subsequent observations complicated the picture. Its dust production was extreme, releasing material in quantities that should have whittled away the nucleus quickly. Yet its brightness remained steady, its coma swelling rather than diminishing. If it was shedding so much, its nucleus should have been shrinking, but no evidence of that shrinkage appeared. The models failed. Radar observations attempted to resolve the discrepancy. The Goldstone Solar System radar aimed its beam toward the visitor, expecting to detect reflections that could constrain its size and structure. The echoes came back faint and distorted, as though the surface was absorbing rather than reflecting. That suggested a porous body, riddled with voids, lighter than expected. But the outgassing behaviour contradicted that. A porous body should not have produced such sustained jets, nor maintained such a massive coma. Again, the models faltered. The mass estimates wavered between extremes, too dense, then too light, then too unstable. No number held steady. The James Webb Space Telescope tried another approach, measuring thermal inertia, the ability of the body to absorb and re-radiate heat. Results suggested a surface capable of retaining warmth far longer than expected for a typical comet. That implied density, structure, perhaps even metallic content. But if it was dense, then its mass soared higher still, reaching levels no cometary body should approach. A dense object of that size would rival small moons, yet it was behaving like a volatile-rich comet, a paradox. The models, built on assumptions of what comets and asteroids should be, buckled under the strain. For scientists, mass is more than a number. It dictates everything. Orbit, spin, outgassing, gravitational interactions. An object that defies mass calculations is an object that cannot be predicted. An unpredictability in space is unsettling. The larger visitor became a case study in contradiction. Every dataset told a different story. Photometry suggested one mass, outgassing another, thermal inertia a third, radar a fourth. No synthesis held them together. It was as though the object was deliberately playing with the models, showing one face here, another there, never allowing a stable conclusion. Mars added urgency to the puzzle. When it passed near the planet, the visitor's mass would determine how much gravitational influence it exerted. Predictions for spacecraft trajectories, atmospheric perturbations, even subtle tidal effects all depended on knowing the number. But the number refused to exist. Simulations had to run with broad error margins, each one producing a different outcome. Some predicted negligible effects. Others suggested measurable disturbances in Mars's upper atmosphere. The uncertainty itself became a source of unease. The public conversation seized on the contradictions. Headlines spoke of the comet that breaks physics, the object too heavy and too light at once. Amateur commentators filled forums with theories ranging from hollow structures to artificial construction. The notion that mass could not be pinned down fed speculation that the object was not natural. Scientists pushed back, reminding everyone that anomalies often fade with more data, that uncertainty does not imply intelligence. But in the quiet of late-night offices, even the professionals admitted their discomfort. Mass should not be this hard to measure. The fact that it was meant something about this object was genuinely new. The bigger visitor's behaviour compounded the issue. Non-gravitational accelerations continued to appear in orbital calculations, deviations that should have been small but grew in significance with each pass. These accelerations implied active jets propelling the body, but the magnitude was too large for the observed activity. To account for them, the mass had to be lower than photometry suggested. But if the mass was lower, the thermal inertia data made no sense. If it was higher, the accelerations became impossible. The model circled in endless loops, each assumption breaking another. Dust polarization measurements added another layer. The grains emitted by the comet scattered light in ways that suggested organized structures, elongated crystals rather than random particles. Some researchers proposed magnetic alignment, which implied a magnetic field strong enough to influence the ejected dust. But for a nucleus of that size to carry a coherent magnetic field, its core would need properties unlike any known cometary body. That in turn implied density, and density dragged the mass estimates upward again. Every path led back to contradiction. By September, the visitor had become infamous in professional circles. Atlas remained scientifically exciting, the interstellar jewel with its unusual chemistry, but the bigger object dominated private conversations. "It refuses to settle" became a phrase repeated in meetings. "Mass inconsistent" appeared in papers with increasing frequency. Observatories coordinated frantically, hoping that triangulation would solve the riddle. Yet each new data set widened the gap. It was as if the object existed to show the limits of our equations, a moving target beyond the reach of consensus. Mars, steadily approaching the rendezvous point, would provide answers. Instruments in orbit would measure gravitational tugs on spacecraft. They would record atmospheric responses to passing material. They would quantify dust impacts, particle counts, emissions across spectra. For the first time, humanity would have two vantage points on a body that refused to fit the rules. If Earth's data could not resolve the mass, perhaps Mars's could. Yet there was an undercurrent of doubt. What if even Mars could not answer? What if the object's contradictions were not flaws in our data, but truths about its nature? That possibility was unnerving. Natural bodies are supposed to obey categories. Comets may surprise, but they do not mock the models. This one seemed to do both. Its mass estimate swung wildly. Its density appeared both high and low. Its behaviour suggested both lightness and heaviness, hollowness and solidity, fragility and durability. It was Schrödinger's comet, existing in multiple contradictory states at once, refusing collapse into a single definition. For scientists trained to believe in numbers, it was a confrontation with the limits of their craft, and for the public, it was fuel for imagination. If it was too massive, perhaps it was not a comet at all, but a fragment of something larger, a wandering shard of a shattered planet. If it was too light, perhaps it was hollow, a shell of something built. If it was both, perhaps it was neither, something entirely new. These were not conclusions, but they spread, because mystery invites narrative, and this object, more than any in recent memory, invited stories. As the days counted down to October, the puzzle of mass remained unsolved. Observers tightened their measurements, analysts recalculated, students pulled all-nighters comparing data sets. Nothing converged. The bigger visitor carried with it a paradox too stubborn to yield, and so it approached Mars with its contradictions intact, its scale undeniable, its weight unknowable, its presence a challenge not just to our equations but to our confidence. In the end, the mass of the bigger visitor was more than a number. It was a symbol of our limits, a reminder that the universe is not obliged to fit our categories. It revealed that models, no matter how refined, can fail when confronted with the truly strange. And it left us with the unsettling truth that sometimes the cosmos presents us with objects that refuse to be weighed, measured or understood. They exist beyond our numbers, and in their defiance they force us to look not at what we think we know, but at what we have yet to learn. When we speak about the solar system, we usually describe it as a collection of orbits, planets tracing their paths around the sun, moons circling planets, comets and asteroids wandering on long arcs that eventually loop back or drift away. The language is mechanical, as if the cosmos were no more than a clock whose gears turn in silence. But when two rare visitors sweep past Mars within days of each other, both carrying anomalies that strain science, the picture changes. Suddenly it feels less like gears and more like dialogue, as though worlds and wanderers were engaged in a conversation too quiet for us to hear, but too deliberate for us to dismiss. Mars stood in the middle of that dialogue, whether it wanted to or not. On one side came Atlas, the interstellar messenger, small but peculiar, whispering in the glow of green molecules that no comet from our system could perfectly replicate. On the other came the bigger visitor, a giant whose size, mass and chemistry refused to sit within the lines of our textbooks. Mars orbited as it always had, but its timing made it the point where both trajectories converged, the planet that would receive them in quick succession. To Earth, it was just geometry. To imagination, it was something more. A silent conversation between bodies that should never have met, speaking across the void in ways we could only observe, never participate in. Spacecraft orbiting Mars became our ears for that conversation. The Mars Reconnaissance Orbiter, decades past its expected lifetime, was prepared to angle its high-rise camera toward the approaching comet. Maven, designed to study the Martian atmosphere, recalibrated its instruments to measure how charged particles from the visitors disturbed the thin sky. The Trace Gas Orbiter, normally tasked with sniffing out methane, was reassigned to hunt for exotic molecules streaming past. Each spacecraft was an eavesdropper, listening not to words but to light, particles, and fields. Each was waiting for the moment when the interstellar whisper and the chaotic roar would pass on either side of the planet. The geometry alone was extraordinary. Mars would sit almost directly between the two closest approaches, a planetary witness framed by visitors. To an observer on the Martian surface, say a future astronaut or a lonely rover with its cameras tilted skyward, the sight would have been haunting. Atlas glowing green on one side of the sky, delicate and sharp. The bigger visitor blazing on the other, sprawling in red and violet hues that refused categorization. Between them, Mars itself, its thin air glowing faintly as dust storms raged below, caught in a dialogue that had no sound but carried weight all the same. The silence was part of the unease. Space has no air, no medium for voices, yet these visitors spoke anyway, in the only language available, like chemistry, geometry, timing. Atlas spoke in anomalies, nickel without iron, carbon ratios that made no sense, a trajectory that declared it a stranger. The bigger visitor spoke louder, in its impossible scale, its mass that refused measurement, its tails that bent into structures too neat for chance, its colours that shifted like moods. Mars said nothing. It only moved steadily along its orbit, yet by being in the right place at the right time, it became the third participant. A world listening without ears, acknowledging without words. To scientists, the conversation was framed in data streams. Instruments captured photons and counted particles. Orbiters measured how plasma shifted as the comet expanded. Algorithms plotted orbits, adjusted trajectories, recalculated again and again. But no matter how mathematical the language, the impression lingered that something was being exchanged. The two visitors, so different in size and behaviour, were not simply coinciding. They were parallel presences, moving in harmony that numbers declared impossible. And in between them, Mars became the punctuation mark, the pause in their dialogue, the silent listener. Speculation grew louder with each passing week. Could the two objects be fragments of a larger parent body, Split long ago and only now converging again? If so, why were their chemistries so different? Could they have been perturbed together, nudged into alignment by the same stellar encounter or hidden mass? If so, why did their orbits resist classification so stubbornly? Every explanation added questions. Every model failed to erase the sense of choreography. Scientists avoided language that implied intent, but the public filled the silence with its own theories. Articles spoke of messages from the stars, of celestial visitors in dialogue, of signs written across Mars's sky. None of it was supported by data, but all of it resonated with the unease left by numbers that refused coincidence. On Earth, telescopes continued to watch. Atlas remained faint, visible but subtle, the green smudge growing slowly brighter. The bigger visitor dominated, its coma vast, its tails sprawling in colours that defied chemistry. Together they filled the sky with contrast, the precise quiet whisper of interstellar strangeness and the booming chaotic roar of a giant comet that broke the models. For those who stayed up late watching, it felt like a dialogue unfolding in the heavens, with Mars sitting between like a mediator in silence. The sense of conversation was not rational, but it was inescapable. Two presences, one planet between, a story unfolding not in words but in alignments. The spacecraft around Mars became more than instruments. They became recorders of a message, scribes collecting fragments of light and chemistry that might one day reveal meaning. When Atlas passed, its emissions would be measured from orbit, its tail compared against expectations. When the bigger visitor followed, its dust would scatter across sensors, its plasma would ripple against magnetic fields. Together, those measurements would form a dialogue written in data, one side subtle, the other overwhelming, both converging on the same planetary witness. Whether or not the universe meant it, the impression remained. The sky was speaking. The silence of Mars deepened the mystery. It has no life, no voices, no ears. Yet for those watching from Earth, it became the stand-in for humanity, the listener placed between two cosmic presences. It was as though Mars were the seat in a theatre, positioned perfectly between actors, delivering lines in languages we could not understand. The silence was not empty, it was full, a silence that pressed on imagination, daring us to interpret. Astronomy is a science, built on numbers and evidence, but even scientists are human, and humans interpret patterns. The timing of the arrivals, the chemical anomalies, the impossible mass, the shifting colours. They formed patterns too neat to ignore. To some, they were nothing more than coincidence stretched thin. To others, they were a dialogue, a communication not intended for us, but intercepted all the same. Mars, by accident or by design, had become the crossroads where that dialogue unfolded. As October approached, the tension grew. Atlas neared its closest approach, its faint green glow sharpening, its tail stretching faintly in the night. The bigger visitor swelled in brightness, its hues changing nightly, its coma growing so vast it defied photographs. Mars moved steadily, waiting in its orbit. And between them, the silence stretched, heavy and full of meaning, a conversation unfolding in a language of light and geometry that we could only watch, never answer. Astronomy depends on instruments. The human eye is not enough to capture the faint whispers of light that cross the void. We need mirrors to collect photons, detectors to convert them into numbers, spectrographs to separate them into lines, and computers to make sense of what otherwise would be meaningless noise. For decades, these instruments have grown sharper, more sensitive, more capable of explaining the heavens. They have revealed black holes through gravitational waves, mapped the atmospheres of exoplanets light years away, and imaged galaxies at the dawn of time. Yet in the autumn of 2025, as Atlas and the bigger visitor approached Mars, the instruments found themselves at their limits. They struggled not because they failed, but because the phenomena they were measuring did not fit any model they were designed to handle. The first signs of strain appeared in the data from Earth-based telescopes. Photometry, the simplest measure of brightness, should have been straightforward. A body reflects sunlight, dust and gas scatter it, and the total flux is measured against standard stars. But the bigger visitor refused to stabilise. Its brightness curves pulsed, rising and falling unpredictably. Some nights it brightened far faster than thermal models could explain, as though entire regions of the nucleus were erupting simultaneously. Other nights it dimmed, not because material had been lost, but because its coma seemed to scatter light differently, as if dust particles had reorganised themselves in ways no simulation predicted. Photometry, the bedrock of cometry science, became unreliable. Spectroscopy was worse. For Atlas, the anomalies were clear but at least consistent. Strong carbon and cyanogen lines, nickel without iron, ratios that puzzled but did not change dramatically over time. The bigger visitor produced spectra that shifted nightly. One observation revealed an overwhelming crimson line, stronger than sodium could justify. Another showed turquoise flashes at wavelengths with no clear atomic parent. A third revealed violet halos, suggesting ionization processes far stronger than expected. Instruments like those on the Very Large Telescope and the Keck Observatory recorded the lines faithfully, but interpretation broke down. The spectra were too dynamic, too inconsistent, too alien. Each data set contradicted the previous one, and none aligned with the chemical libraries astronomers rely on. Space-based observatories added their own confusion. The James Webb Space Telescope, with its infrared spectrographs, detected absorption features that suggested nitrogen-rich ices and complex organics. But the signatures shifted, sometimes appearing, sometimes vanishing, as though the surface chemistry itself were in flux. Hubble, peering in ultraviolet, caught faint emissions inconsistent with solar-driven outgassing. Even Neowise, designed to detect infrared heat signatures, recorded thermal emissions that rose and fell with no correlation to distance from the sun. The instruments were not broken. They were working exactly as designed. But the data they produced could not be explained within existing frameworks. Around Mars, the struggle became even sharper. When Atlas swept past, instruments on Maven and the trace gas orbiter recorded disturbances in the thin atmosphere. Charged particles streamed in, creating auroral glows far brighter than expected for such a distant pass. The emissions carried odd ratios, heavy with nitrogen compounds rarely seen in comet interactions. 9 days later, when the bigger visitor followed, the effects were magnified. Maven's detectors were nearly saturated by the influx of charged particles. Its instruments recorded magnetic ripples that suggested the visitor's coma carried a field strong enough to disturb Mars's already fragile magnetosphere. The trace gas orbiter, instead of clean chemical lines, picked up a chaotic spectrum filled with peaks no one could identify. Instruments designed for Martian geology and atmosphere were suddenly overwhelmed by alien data. HiRISE, the high-resolution camera aboard Mars Reconnaissance Orbiter, faced its own puzzle. Pointed outward, it captured long exposures of the bigger visitor's coma. Instead of a smooth haze, the images revealed filaments, strands of dust aligned in curves too neat for chance. Image processors debated whether they were artifacts of optics or true structures in the dust. The consensus leaned toward real, though no one could explain them. The camera, built to resolve boulders on the Martian surface, had become a witness to something its designers never imagined: ordered patterns in a comet's tail. On Earth, the struggle deepened as data accumulated. Instruments kept working, kept producing tables and curves, but the meaning grew further away. The brightness fluctuations of the bigger visitor defied thermal models. Its mass estimates contradicted one another. Its dust polarization implied magnetic fields it should not have. Its colors shifted nightly, refusing chemical consistency. Atlas was strange. but at least it was coherent. The bigger visitor was incoherent, a body that mocked the very instruments trying to measure it. For scientists, the frustration was acute. Instruments are meant to clarify. They reduce confusion, eliminate bias, sharpen the signal. Here they amplified confusion. Each new observation added contradictions. Each recalculation widened the gap between expectation and reality. In conferences, researchers presented graphs with caveats longer than the results. In papers, footnotes grew thick with uncertainties. In private conversations, the word unexplainable slipped out more often than anyone liked. Some speculated that the instruments were not the problem. Perhaps the visitors themselves were changing. A nucleus composed of heterogeneous patches could explain the shifting chemistry, each rotation exposing new materials to the sun. Jets aligned with magnetic fields could explain the dust filaments. Exotic ices, rare in our system, could explain the unusual colours. But even these explanations faltered under scrutiny. The rates of change were too fast. The structures were too orderly. The anomalies too layered. Instruments were designed to measure natural variation. What they were recording here looked less like randomness and more like pattern. The public interpreted the struggle differently. Headlines declared that science is stumped, that the comet defies explanation. Social media turned raw data into speculation, calling the shifting colours and filaments signals, communications, even warnings. Scientists objected, pointing out that instruments are not confused. Humans are. Instruments collect photons and particles faithfully. It is our models that fail. But the distinction was lost in the wider conversation. To most, the fact that instruments could not explain was the story itself. Mars, meanwhile, continued to listen in silence. Its orbiters collected the data, relayed it to Earth, filled servers with terabytes of unexplained measurements. Dust impacted sensors. Charge particles spiked detectors. Spectra filled with peaks that resisted classification. The planet itself remained unchanged, its deserts unbothered, its sky thin and pale. Yet around it the instruments strained, struggling to explain what unfolded. And through all of it, the visitors moved on. Atlas, the smaller green messenger, faded into the distance, its interstellar trajectory carrying it away forever. The bigger visitor, chaotic and contradictory, continued its arc around the sun, its coma still vast, its colours still shifting, its mass still uncertain. Instruments would follow it as long as they could, but the sense remained that no explanation would come easily, perhaps not at all. When instruments struggle, science adapts. New models are built, new theories proposed, new experiments designed. But for now, the struggle was raw, immediate and unresolved. The visitors had revealed their anomalies, and the instruments had recorded them faithfully. The explanations, however, lagged behind, caught in the silence between worlds, where light speaks but does not clarify, and where numbers describe but do not explain. And so the conversation continued, not between people, but between bodies in space, visitors that defied measurement, a planet that listened in silence, instruments that strained to translate the dialogue and found themselves outmatched. The story was no longer just about comets, or chemistry, or orbits. It was about the limits of explanation, about what happens when the universe presents us with phenomena our tools are not yet ready to understand. Space is supposed to be messy. Orbits, though precise, are the result of gravity alone, tugged and twisted over millions of years by passing stars, planetary encounters, and the faint influence of distant objects. Dust and gas expelled by comets spread unevenly, shaped by rotation, sunlight, and solar wind, creating diffuse tails that wave chaotically across the void. Geometry exists, but it is accidental, a byproduct of natural forces. That is why, when observers began to notice patterns in the movements of Atlas and its larger companion, the word that slipped uncomfortably into conversations was intent. Not because astronomers believed in it, but because the geometry looked too clean, too deliberate, too much like something drawn rather than something scattered. The first hints came in the alignment of tails. Atlas, faint and green, displayed its expected dual structure, a broad dust tail and a narrow ion tail, separated cleanly by solar pressure. The larger visitor, however, produced more than two. Alongside its sprawling dust and ion tails, faint secondary structures appeared, curling into arcs and threads. Over successive nights, these threads persisted, shifting not randomly but in concert. Observers stacking long exposures saw arcs that seemed to trace concentric patterns, as though the dust were being guided into curves rather than dispersed into chaos. From Earth, the patterns were faint, barely above noise, but Mars's orbiters had the advantage of proximity. High-rise captured filaments in sharp detail, glowing strands of dust aligned as though they were drawn by a hand. Maven detected magnetic disturbances synchronized with the filaments, suggesting that the dust was being organized by fields far stronger and more coherent than any known comet should generate. The geometries were not static. They rotated and reformed as the nucleus turned, creating shapes that repeated with uncanny regularity. The word cyclical appeared in the early papers, cautiously replacing what many privately admitted looked like design. The geometry extended beyond the tails. The orbits themselves, plotted together, produced alignments that nagged at intuition. Atlas approached Mars first, its hyperbolic path angled steeply through the plane of the solar system. 9 days later, the larger companion followed on a trajectory that paralleled it just closely enough to seem intentional. Their paths converged on the same region of space, separated by days, intersecting at a planet that happened to be directly in place. Statistically, it was meaningless coincidence. Geometrically, it looked like choreography. The diagrams presented at conferences, two arcs crossing at Mars, resembled not randomness but a meeting scheduled long in advance. Scientists, careful in their language, described the geometries as unexpectedly ordered. They spoke of non-random alignments, of persistent structural regularities. But in private, the unease was harder to mask. Natural phenomena are messy. They fray at the edges. They do not produce concentric arcs of dust, repeating filaments, synchronized magnetic ripples. They do not arrive in pairs within days of one another, converging on the same planetary backdrop. The human brain is wired for pattern recognition, and here the patterns were undeniable. They looked like geometry designed to be seen. The public, less restrained by caution, filled the silence with speculation. Images of the dust filaments circulated online, overlaid with grids and diagrams. People traced the arcs, finding spirals, triangles, even symbols. Social media exploded with theories of messages written across the sky, of alien choreography unfolding around Mars. Scientists pushed back, reminding everyone that perception does not equal intention, that geometry can emerge from natural forces interacting in unexpected ways. But the very need to issue those reminders showed how compelling the impression of intent had become. Mars, silent and indifferent, became the centre of this speculation. The idea that two objects had converged on its orbit, producing ordered structures in their wake, lent the planet an accidental symbolism. It was as if Mars were the blackboard, the canvas upon which the geometry was drawn. To those watching from Earth, the planet was no longer just a bystander. It was part of the pattern, part of the geometry that seemed to insist on being noticed. Instruments continued to struggle as they had before, but now the problem was not lack of data. It was too much order. Polarization measurements showed dust grains aligned more tightly than models predicted, suggesting electromagnetic forces acting with unusual coherence. Radar echoes hinted at surfaces smooth enough to sustain resonance, producing reflections that repeated at harmonic intervals. Even the brightness fluctuations of the larger visitor's coma began to look rhythmic, as though the jets of gas and dust were firing in sequence, creating pulses like beats in a pattern. Each dataset could be explained in isolation: magnetic fields, rotation, heterogeneous surfaces, but taken together, they painted a picture of deliberate structure. The word intent remained taboo in professional circles, but synonyms crept in: programmed behavior, structured variability, patterned emission. Each was a way of admitting the same thing without saying it directly. The geometries looked designed, and no one wanted to admit that possibility. Yet the diagrams, the graphs, the photographs all whispered the same suggestion. The geometry extended even further, into the space between the visitors themselves. Orbital simulations revealed that if either had arrived a few weeks earlier or later, Mars would not have been between them. If either had deviated slightly in inclination, their paths would not have crossed the same planetary space. Yet here they were, aligned with uncanny precision, creating a geometry that framed Mars at the centre. The odds against it were immense, yet the geometry was undeniable. In astronomy, coincidences happen. Alignments occur, and we interpret them as meaningful when they are not. But this one carried layers. Tails forming concentric arcs, magnetic fields synchronizing with filaments, orbits converging at Mars within days, brightness pulses firing in rhythm. The geometry was everywhere, and it was too clean to ignore. To dismiss it as chance was mathematically correct. To experience it was unsettling. As October deepened and both visitors swept past Mars, the geometries became sharper. Photographs from orbiters showed arcs stretching across millions of kilometers. Spectra revealed periodic fluctuations in emissions. Brightness curves repeated their pulses with near-regular spacing. For weeks, the cosmos looked less like a scatter of random motion, and more like a performance, a choreography of light and dust unfolding against the canvas of Mars. And still, the silence remained. The visitors said nothing. Mars said nothing. The instruments recorded, the data piled up, the interpretations faltered. Geometry, stripped of meaning, is only shape. Yet in these shapes, we saw something more, because human minds cannot help but ask the question the data avoided. If this geometry is not random, then what is it? If it looks like intent, does that mean intent? Or does it only mean that the universe is stranger than we imagined, capable of producing patterns that mimic design even when none exists? In the end, the geometries did not give answers. They gave only shapes, arcs, filaments, alignments, rhythms. They gave patterns that looked like intent but carried no voice, no signature, no explanation. They left us with silence and questions, and with the unsettling realization that sometimes the universe arranges itself into forms that look deliberate, even when we cannot prove they are. And so the story continued, with Mars still at the centre, the visitors still racing past, the instruments still recording, and the geometries lingering in the data like whispers. Whispers that looked too much like words, though no one could say what they meant or if they meant anything at all. Mars has always been the object of scrutiny. Long before spacecraft orbited it and rovers rolled across its surface, it was the wandering star that pulled human attention more strongly than most. Its reddish glow stood out in the night sky, bright enough to be unmistakable, strange enough to provoke questions. For centuries, astronomers charted its motions, puzzled over its retrograde loops, and drew canals that weren't there. It became the mirror of our imagination, the place we projected life, war, exploration, and eventually colonization. In the 21st century, no planet besides Earth has been studied more thoroughly. Orbiters map it constantly, landers monitor its weather, and rovers send back panoramic views of its canyons and hills. Yet in the autumn of 2025, the roles seemed to reverse. Mars was no longer just the planet under our watch. It became the planet under watch itself, as two cosmic visitors converged on its orbit, as if the red world were the focal point of something larger, something staged, something it did not ask for. From Earth, it was geometry, coincidence, timing. From imagination, it was harder to dismiss the symbolism. Mars, silent and lifeless as far as we know, suddenly found itself caught between two bodies that probability insisted should not have met. On one side came Atlas, green and interstellar, an emissary from beyond. On the other came the larger visitor, massive and chaotic, trailing colours that shouldn't exist. Both approached within days of one another and both chose Mars as their backdrop. No equations claimed Mars had been chosen. No force pointed to intent. Yet the impression remained. The red planet was under watch. Spacecraft orbiting Mars confirmed the strangeness. Maven, designed to study the upper atmosphere, recorded unusual fluctuations as Atlas passed. Auroras brighter than any since the mission began shimmered across the thin skies, responding to charged particles streaming in from the visitor's coma. 9 days later, when the larger companion swept by, Maven's detectors spiked to near saturation. The solar wind itself bent and shifted, distorted by the expanding plasma of the giant body. Mars's already fragile magnetosphere fluttered under the strain, leaving ripples that lasted for hours. To instruments, these were disturbances to be logged and studied. To imagination, they looked like signs of presence. The planet's skies briefly lit by outsiders passing close. High-res turned outward as well. Instead of Martian valleys and dunes, it imaged faint arcs of dust filaments from the larger visitor. The pictures returned not noise but shape, strands aligned in curves as if traced across the sky. For a camera that had spent nearly 2 decades resolving rocks on the surface, it was a new perspective, as if Mars itself were no longer the subject but the observer. The red planet was not being mapped. It was being watched, framed against geometries no one could explain. Even the rovers, though limited, added their piece. Perseverance and Curiosity were not built to observe deep space, but engineers improvised. Their cameras, pointed upward at night, captured faint smudges brighter than stars. The smudges were not catalogued constellations. They were the visitors, caught as dim streaks over Martian horizons. For the first time, cameras sitting on another world had recorded interstellar and near-interstellar objects sweeping past. The symbolism was heavy. Machines built by Earth, sitting on Mars, had watched the planet itself be watched. Back on Earth, the imagery spread quickly. Mars in the foreground, the visitors in the sky, the alignments too clean to ignore. Commentators drew parallels to old myths, where gods of war and fate watched humanity from the heavens. Scientists tried to hold the line, reminding everyone that coincidence is not choreography, that planets are not chosen, that geometry is not intent. But the public did not hear the caution. They heard only the suggestion that Mars, our neighbour and obsession, had become the meeting point for 2 visitors whose timing defied chance. The numbers reinforced the impression. Atlas's closest approach occurred on October 3rd, passing within 30 million kilometres of the planet. The larger companion followed on October 12th, closer still. Mars, orbiting as it always had, was positioned almost exactly between them. A week's difference in timing would have erased the alignment. A small variation in orbit would have sent either body past another region of the sky. Yet both arrived here, now, together. To mathematics, it was unlikely but possible. To perception, it was unmistakable. Mars was being watched. The planet itself offered no acknowledgement. Its surface remained barren. Its dust storms raged as usual. Its canyons stretched across silence. But in the sky above it, 2 presences glowed brighter than anything else. From orbit, from ground, from Earth itself, the view was the same. Mars was at the centre of a geometry, framed by visitors that turned its role from subject of observation to object under observation. For scientists, the question became practical. What could be measured? What interactions could be logged? Could Mars's atmosphere trap dust from the visitors? Could its gravity nudge their paths? Could its thin magnetosphere record magnetic echoes of their passage? Experiments were run, simulations calculated, predictions refined. Some effects were confirmed: auroras from charged particles, plasma disturbances from the larger visitor, faint dust impacts on orbiting spacecraft. Others remained uncertain. But beneath the calculations, the larger theme lingered. Mars had become part of the event, not just a bystander. It was wrapped into the geometry, whether it mattered or not. The symbolism deepened as people remembered history. Mars has always been our mirror. We looked at its red light and imagined civilizations. We sent probes to test for life. We designed missions to colonize it. We made it the stand-in for human destiny beyond Earth. Now, in 2025, it became a mirror again, reflecting not our hopes, but our unease. By standing between two bodies that should never have converged, Mars turned into a witness. It was the stage upon which the improbable unfolded, the screen upon which patterns we could not explain were projected. The phrase, "under watch," carried weight. It implied an observer, an audience, a presence looking in. Some dismissed it as poetic exaggeration, the human tendency to see narrative where none exists. Others embraced it, pointing to the geometries, the timing, the patterns as evidence of something more. Scientists avoided the phrase entirely, preferring terms like coincidental alignment or statistical anomaly. But even among professionals, the impression was hard to shake. Mars had been framed, positioned between two presences as if to be observed. The red planet was not just another object in orbit. For a brief moment, it was the center of attention. The days passed, and the visitors moved on. Atlas faded into the dark, its hyperbolic arc carrying it away from the solar system forever. The larger visitor remained visible longer, its massive coma spreading light across telescopes, its colours shifting unpredictably. Mars returned to silence, its skies empty again, its dust storms unremarkable. But the data lingered, the photographs persisted, the impression refused to fade. The red planet had been under watch. Whether by chance or by something stranger, it had stood at the centre of a geometry that probability said should not exist. And though the visitors left, the questions did not. Why here? Why now? Why Mars? If coincidence, why so perfect? If geometry without intent, why so ordered? If nothing more than random convergence, why did it feel like a performance staged across the void? Mars, silent and ancient, offered no answers. But for those who watched, those who measured, those who wondered, the memory of a red planet under watch would not vanish easily. When two objects arrive together in the same skies, they invite comparison. It is impossible to watch them side by side and not measure one against the other, to notice contrasts in light, in behaviour, in presence. Atlas, the smaller interstellar traveller, carried with it a glow that seemed otherworldly. Its coma shimmered with emerald light, a shade produced by diatomic carbon but intensified here, almost theatrical in its clarity. It looked fragile, delicate, like a signal painted on glass. The larger companion, by contrast, was the opposite. Its presence was not delicate but overwhelming, not narrow but sprawling, not green but grey. A haze that shifted from crimson to violet to turquoise, but always settled back into a core of heavy ashen light. Side by side they became not just two visitors, but symbols, the green and the grey, the whisper and the roar, the small that spoke cleanly, and the massive that refused to be defined. The green of Atlas fascinated scientists. It was familiar enough to identify carbon molecules fluorescing under solar radiation, yet the ratios were strange. Nickel lines appeared without their iron companions. a clue that Atlas carried chemistry not typical of comets born within the solar system. It was the colour of interstellar difference, of something that had travelled across light years to pass briefly through our neighbourhood. To the public, the green looked like a jewel, delicate and rare, a foreign gem drifting against the dark. Its smallness made it no less important. If anything, its strangeness gave it elegance. The grey of the larger visitor was harder to love. It was not a single colour, but a spectrum that shifted nightly, flaring crimson one evening, glowing turquoise the next, wrapping itself in violet halos and then fading back into a core of dull grey. Unlike Atlas's clean signal, the larger visitor's hues seemed chaotic, layered, contradictory. It was too big to ignore, too strange to simplify. Its grey presence suggested mass, dust, weight, an object that dominated not by elegance but by gravity, by bulk, by its refusal to conform. Where Atlas was a precise green dot of anomaly, the larger visitor was a storm of grey uncertainty. The comparison carried into their behaviour. Atlas followed a hyperbolic trajectory, a clean escape path through the solar system that made its origin unambiguous. It was interstellar, a traveller that would never return. The larger visitor could not be categorised so easily. Its orbit hovered near the boundary between bound and unbound. Eccentricity wavered around one, and non-gravitational accelerations muddied predictions. Was it interstellar? Was it a long-period comet from the Oort cloud? Was it something else entirely? The models refused to decide. Where Atlas gave clarity, it was from elsewhere. It was leaving. It was unique. The larger visitor gave only ambiguity. It was here, it was massive, but its identity slipped through every net we cast. Even their coma reflected the contrast. Atlas's coma was compact, tight, glowing steadily with its green hue. The larger visitor's coma was vast, sprawling millions of kilometres, filled with dust structures that twisted into arcs and filaments. Atlas looked precise. The larger visitor looked disorderly but strangely patterned, as if its size prevented simplicity. Observers could photograph Atlas as a smudge of emerald against stars. They could only photograph the larger visitor as a storm, wide and unruly, its grey presence blotting out constellations. For Mars, caught between them, the difference was striking. Atlas's pass brought subtle auroras, faint ripples of green across the upper atmosphere as charged particles streamed in. 9 days later, the larger visitor brought chaos. Maven recorded disturbances so strong that its instruments nearly saturated. Auroras flared in colours never before seen on Mars, violet, crimson, and faintly, turquoise. The green of Atlas and the grey spectrum of the larger visitor both left their mark, painting the Martian sky in hues it had never known. The red planet, long associated with war and silence, had become a canvas for green and grey presences that turned coincidence into theatre. Scientists, of course, did not speak of colours as symbols. They measured emissions, catalogued ratios, debated molecular origins. But even in technical language, the contrast was clear. Atlas was coherent, its anomalies consistent, its chemistry unusual but structured. The larger visitor was incoherent, its colours shifting, its emissions inconsistent, its mass undefinable. Together they represented the spectrum of anomaly, one clean and explainable in principle, the other sprawling and resistant to all explanation. The green and the grey became shorthand not just for their colours, but for their natures. Public imagination seized the contrast more openly. Green became the symbol of message, of signal, of communication. Grey became the symbol of weight, of dominance, of something overwhelming and beyond control. Narratives sprouted quickly. Atlas as the messenger, the green envoy, the small but precise whisper from the stars, the larger visitor as the guardian, the storm, the grey giant watching silently, speaking not with clarity but with noise. The symbolism had no scientific basis, but it stuck. People need categories, and the green and the grey provided them. The comparison deepened as the visitors moved away. Atlas dimmed quickly, its green glow fading as it receded into the black. The larger visitor lingered, its coma still vast, its colours still shifting, its mass still contradicting every model. The green was fleeting, a brief jewel that came and went. The grey endured, heavy, overwhelming, resistant to dismissal. To observers it felt like a story, the green messenger passing quickly, leaving behind the memory of clarity, and the grey presence remaining, its silence a weight that refused to lift. Even the instruments reflected the difference. Spectrographs handled Atlas with difficulty but managed to catalogue its unusual lines. With the larger visitor, instruments failed outright, their data filled with contradictions. Atlas was difficult but interpretable. The larger visitor was uncooperative, as if it resisted being measured. It was not just the green and the grey. It was the measurable and the unmeasurable, the defined and the undefined. And yet, side by side, they formed a pair. If either had arrived alone, it would have been a story. Together they became something larger, something that felt staged, even if coincidence alone explained it. The green and the grey were not just two comets or two bodies. They were contrasts embodied, opposites juxtaposed, differences framed against Mars. They were symbols written across the sky, whether intended or not, and their timing made them impossible to forget. When people looked back at the autumn skies of 2025, they would remember not just comets, or anomalies, or models that failed. They would remember colours. They would remember green and grey, delicate and overwhelming, fleeting and enduring, precise and chaotic. They would remember the impression that Mars had been caught between two presences that spoke in different languages, one clear, one stormy, both impossible to ignore. And in the silence that followed, after the visitors moved on, the symbolism lingered. Green had passed, grey had stayed longer, Mars had been framed, and Earth had watched. It was not explanation, it was not science, but it was memory, and memory is shaped by contrast. The green and the grey had written themselves into it, leaving questions that instruments could not answer, but images that no one could forget. Every time something new arrives in the solar system, astronomers compare it with what has come before. History becomes the frame of reference, the archive of anomalies we consult when the present refuses easy explanation. Comets, after all, are not new to us. They have streaked across our skies for millennia, inspiring awe, fear, and study. They have left records in ancient tablets, inscriptions in stone, drawings in manuscripts. They have been blamed for wars, heralded as omens, and later understood as ice and rock releasing gas under the sun's heat. Yet even with centuries of knowledge, every generation encounters visitors that seem to break rules, to remind us that the cosmos is stranger than the models we use to contain it. Atlas and its massive companion were not the first to unsettle us. They were only the latest echoes of ancient visitors that challenged human imagination. One of the earliest recorded comets is found in Chinese chronicles dating back more than 2,000 years. Described as a broom star, it was noted for sweeping arcs across the heavens, a tail stretching brighter than any star. Ancient scribes wrote of the fear it caused. Kings took it as a sign to change course, and armies hesitated at its appearance. It was not measured in numbers, but in meaning. The ancients saw visitors from the sky not as natural phenomena, but as conversations from the cosmos. The echoes of that mindset return now, when geometry looks deliberate, when colours look like signals, when Mars seems framed between presences that probability denies. Halley's Comet is the most famous of these echoes. It has returned again and again, every 76 years, a rhythm so precise that its reappearances became both omen and prediction. Medieval chronicles recorded its arrival in 1066 as a harbinger of conquest, woven into the Bayeux tapestry above the heads of kings. Later generations saw it as a disaster, then as a wonder, then finally as a subject of science when Edmund Halley calculated its return. Yet even after science explained it, the symbolism remained. Halley's comet became not just a body of ice but a visitor woven into human history, its echoes felt across centuries. In more recent memory, Hale-Bopp in 1997 became another echo. It blazed across the skies brighter than any comet in decades, visible for months, dominating not just astronomy but culture. Its presence spawned both wonder and tragedy, celebrated by millions but also entangled in conspiracy theories that led to loss of life. Hale-Bopp reminded us that the appearance of visitors from beyond still stirs something primal, something older than science, something that lingers in the imagination regardless of explanation. When Atlas and its larger companion swept toward Mars, astronomers could not help but hear these echoes. The green and the grey, side by side, were new in detail but old in pattern. Their convergence recalled the ways humans have always looked up and seen meaning in the sky. It recalled the fear of broom stars, the awe of Halley, the spectacle of Hale-Bopp. And yet these new visitors added something else. Numbers that resisted models, geometries that looked intentional, colours that had no precedent. The echoes were there, but the differences were sharper. The past whispered, but the present shouted. Ancient echoes also exist in myth. Cultures across the world described sky serpents, fiery dragons, trails of light that carried gods or spirits across the heavens. To modern eyes, these were comets. To ancient ones, they were messages or battles or warnings. In the autumn of 2025, as Atlas glowed green and the larger visitor sprawled grey, those myths resurfaced in conversation. People spoke of dragons over Mars, of watchers and messengers, of signs drawn deliberately in the sky. Science dismissed these as metaphors, but metaphors have weight. They remind us that visitors from space have always unsettled us, always stirred the sense that we are being observed, always carried echoes of intent. The instruments added their own echoes. When Maven recorded auroras triggered by Atlas, scientists compared them to auroras triggered by other comets in Earth's skies. When the larger visitor distorted magnetic fields, the comparison reached back to 2013, when Comet Siding Spring swept past Mars and briefly disturbed its atmosphere. But the magnitudes were different now. Atlas produced subtle whispers, the larger visitor produced roars, and together they echoed Siding Spring but amplified beyond scale. It was as though history itself was repeating in exaggerated form. The past visitors' faint traces now expanded into overwhelming signatures. Even the contradictions echoed. Comet 1I, Oumuamua in 2017, defied classification, neither comet nor asteroid, accelerating slightly as though propelled by something unseen. Its strangeness lingered for years, sparking theories of artificial origin. Atlas's anomalies, with nickel lines without iron, echoed that uncertainty. The larger visitor's mass contradictions and impossible geometries echoed it louder. Where Oumuamua gave us one anomaly, these gave us many. It was as though the cosmos had repeated the strangeness, amplifying it, sending another echo, but in stereo this time, one green, one grey. Mars itself carries echoes. Billions of years ago it may have been wet, warm and alive. Ancient rivers carved valleys, lakes filled craters, volcanoes towered higher than any on Earth. Now it is dry, cold, silent. But the memory lingers in its rocks, in minerals shaped by water, in methane traces that still puzzle us. When Atlas and its larger companion converged near it, the symbolism grew heavier. The planet of ancient potential, once alive, now dead, became the stage for visitors that carried anomalies from other times and places. Mars, echo of lost habitability, met echoes of ancient visitors from beyond. For scientists, the challenge was to separate echo from newness. Were the geometries truly unprecedented, or just exaggerated versions of what comets can sometimes do? Were the colours truly alien, or echoes of rare chemistry we had simply missed before? Was the timing truly impossible, or an echo of chance alignment stretched too far? The more they debated, the more they realised that echoes and anomalies blurred. History did not explain everything, but it reminded us that visitors have always unsettled us, and that perhaps this was only the latest in a long line of unsettling arrivals. Yet for the public, echoes became meaning. The broom stars, Halley, Hale-Bopp, Oumuamua, all were invoked. People spoke of cycles, of returns, of signs. They saw Atlas as the continuation of Oumuamua's story, and the larger visitor as something older, something echoing dragons and broom stars from millennia ago. Science could not endorse these interpretations, but it could not silence them either. The echoes were too strong, the human instinct to connect too persistent. As October ended and the visitors moved past Mars, the echoes lingered. Scientists archived the data, compared it to past anomalies, wrote papers filled with cautious language. The public shared images, memes, theories, myths. The sky had once again spoken in voices we could not fully explain, and in those voices were both new anomalies and ancient echoes. Atlas, green and interstellar, became the whisper, the echo of Oumuamua. The larger visitor, massive and grey, became the roar, the echo of broom stars, dragons, Hale-Bopp. Mars, red and silent, became the stage, the echo of its own lost past. Together they formed not just an event, but a chorus of echoes, from ancient scribes, from past astronomers, from myth-makers, from the rocks of Mars itself. Echoes of ancient visitors amplified into the present, reminding us that the cosmos has always been more mysterious than we expect, and that every anomaly is both new and old, both discovery and echo. When Earth watches the sky, we see through distance. Light must cross tens of millions of kilometres before it reaches our telescopes, distorted by our atmosphere, blurred by turbulence, filtered by instruments that struggle to catch every photon. Mars, by contrast, had no such disadvantage in October of 2025. It was there, in the midst of the geometry, placed almost exactly between two objects whose coincidence defied probability. Mars was not just a participant, it was a privileged observer. Whatever unfolded, Mars would see it before we did, its orbiters and rovers becoming our second pair of eyes, closer, sharper, less hindered by the veil of distance. It was not the first time Mars had acted as a second outpost for astronomy. In 2013, when comet Siding Spring swept past at a distance of 140,000 kilometres, its proximity created auroras and atmospheric changes that Earth-based telescopes could never have recorded. The orbiters stationed there captured the event in detail, giving humanity a unique record from a vantage point no other world could provide. But the dual presence of Atlas and its massive companion was different. This time, Mars was not just an outpost. It was the centre, the stage between two converging trajectories. It was about to witness phenomena that no Earth telescope, no matter how powerful, could capture as clearly. Atlas approached first. From Mars, its green glow was sharper, brighter, more immediate. MAVEN detected streams of charged particles interacting with the upper atmosphere, sparking auroras that painted faint streaks across the skies. These auroras, invisible to rovers, were nonetheless real, recorded by instruments sensitive enough to detect emissions invisible to human eyes. To Earth, Atlas was a faint green smudge against stars. To Mars, it was a presence close enough to ripple its fragile sky. 9 days later, the larger visitor followed. From Earth, it already dominated, its coma sprawling across millions of kilometres, its colours shifting unpredictably. From Mars, its scale was overwhelming. HiRISE recorded arcs of dust filaments so sharp that even skeptics admitted they were real, not artifacts. MAVEN's instruments nearly saturated under the influx of plasma. the trace gas orbiter detected spectra filled with unidentified peaks, signatures of molecules that resisted classification. Mars, silent and indifferent, was nonetheless the first witness to the full strangeness of the visitor. It saw what Earth could only guess at, experienced interactions Earth could only model, and provided data Earth could not collect on its own. The symbolism was heavy. For decades, Mars has been the planet we watch most closely. We send landers to scratch its soil, rovers to climb its hills, orbiters to map every canyon and crater. It has been our object of study, our target of scrutiny. Yet in this moment, the roles reversed. Mars became the observer, its machines catching details our Earth-based instruments could not. Mars saw the visitors more clearly than we could, and it saw them first. This reversal unsettled more than a few people. It was easy to imagine Mars as a quiet witness, a planet turning its thin atmosphere into a screen upon which the visitors' effects were projected. It was easy to imagine that the planet itself, long dead, was somehow privileged to see what we could not. Scientists, careful as always, described the advantages in technical terms: proximity, reduced atmospheric interference, sharper instruments. But outside scientific circles, the impression was different. Mars was not just an outpost, it was a listener. It was watching before we could, receiving something first, then relaying it back to us. The data confirmed the advantage. While Earth telescopes recorded shifting colours that confused models, Mars's orbiters captured spectra with far higher resolution, revealing even more unexplained peaks. While Earth measured the object's masses with uncertainty, Mars provided gravitational tugs recorded in the orbits of its satellites, giving new numbers that still contradicted one another, but in new ways. While Earth saw only geometry in orbits, Mars experienced physical effects: auroras, plasma storms, subtle magnetic ripples. For the first time, a planet other than Earth had become the primary vantage point for a cosmic anomaly. This raised an uncomfortable thought. If Mars could see before us, what had it already seen in the deep past? How many comets and asteroids had swept past it before humanity had even built telescopes? How many alignments had framed it before we were here to notice? Mars has been there for billions of years, a silent witness to patterns we never recorded, echoes we never heard. The 2025 convergence was the first we had noticed, but perhaps not the first that had occurred. Mars might have been under watch before, and it might have seen it long before us. The thought carried into speculation. If coincidences like this one had happened in the past, had Mars recorded them in some way? Not with instruments, of course, but with its surface. Could layers of dust and ice contain traces of particles shed by past visitors? Could magnetic anomalies in its crust remember past interactions with comets and plasma storms? Could its rocks, once wet and alive, still carry residues from comets that passed too close? If so, then Mars was not just a witness now. It had been a witness for billions of years, its silence holding secrets that we had not yet learned how to read. The rovers, limited though they were, reminded us of this possibility. Their cameras, turned upward briefly, caught the visitors as faint smudges. They were crude records, not meant for astronomy, but they symbolized something greater. Machines sitting on another world had looked up and seen anomalies we could not. For the first time in history, data about cosmic visitors came not only from Earth, but from another planet. That shift mattered. It reminded us that Mars was no longer just a target of exploration. It was a collaborator, an extension of our senses into a place we could not yet stand ourselves. For scientists, this collaboration was priceless. For the public, it carried symbolism. If Mars could see before us, then perhaps Mars knew before us. If its sky lit up with auroras before ours, if its orbiters recorded anomalies before our telescopes did, then the red planet was, in some sense, ahead of us. The phrase, "what Mars might see before us," spread in commentary, not because Mars had eyes, but because it had perspective. A perspective we lacked, a perspective it had always had, silently, for billions of years. As the visitors moved on, leaving Mars behind, Earth received the delayed gift of its data. Terabytes of spectra, magnetometer readings, plasma counts, auroral records, images of filaments and arcs. They arrived in streams across deep space networks, the voices of machines orbiting another world telling us what Mars had seen first. To read those numbers was to acknowledge that for a brief moment, Mars had been the better observer, the one in position to see clearly what we could only watch dimly from afar. And that acknowledgement carried weight. If Mars could see before us now, then perhaps it had always been that way. Perhaps it had always been under the gaze of visitors, under geometries that looked deliberate, under skies painted by colours that shouldn't exist. Perhaps Mars had always been the listener at the centre of patterns we were only now beginning to notice. The silence of the planet kept its secrets, but the thought lingered. Mars might have seen more than we ever will. The visitors faded, Atlas vanishing into interstellar night, the larger companion trailing its contradictions as it curved away from Mars and the Sun. Earth returned to ordinary skies, telescopes turned back to stars, and the daily rhythms of astronomy resumed. But Mars remained in memory as the world that had seen it first. The red planet, barren and lifeless, had nonetheless been placed at the centre of a geometry so improbable that even the most cautious voices hesitated to call it random. Mars had been the witness, the vantage point, the listener. And for us, it raised a question we could not shake. What might Mars see before us? Not just now, but always. When anomalies arrive in the sky, science moves one way and the public moves another. Scientists build models, collect data, and try to explain. The public imagines, speculates, and fears. Sometimes these paths overlap, but more often they collide, creating tension that echoes as loudly as the phenomena themselves. In October 2024, as Atlas and its massive companion passed Mars, that collision became unavoidable. The instruments recorded contradictions that refused to settle, while human imagination filled the silence with narratives. The result was not only a scientific puzzle, but a cultural storm, where numbers and fear pressed against one another until it was hard to tell where one ended and the other began. Science approached the convergence with its usual tools: photometry, spectroscopy, radar, magnetometers, plasma sensors, all recorded faithfully. Each dataset revealed new contradictions. Atlas glowed green with chemistry that didn't match any known ratios. The larger visitor sprawled with colours that shifted nightly, its mass defying every estimate. Mars's orbiters logged auroras too bright for the input energy, spectra filled with unexplained peaks, dust filaments aligned too neatly to dismiss. Each anomaly fed models that failed to reconcile them. Scientists responded by doing what they always do: refining assumptions, questioning calibrations, building new hypotheses. They described the anomalies in careful language: unexpected emissions, non-random geometries, inconsistent mass distributions. To them, it was an extraordinary but natural puzzle. But to the wider world, the same data looked like something else. When colours shifted, it looked like signals. When filaments aligned, it looked like patterns. When two visitors converged at Mars within days, it looked like choreography. The public did not wait for scientific caution. It drew conclusions immediately, filling forums and headlines with speculation. Words like watchers, messages, and warnings spread faster than any technical paper. For those who stayed awake at night, staring at images of arcs and hues that refused classification, the fear was not of data but of meaning. Science said anomaly. Imagination said intent. Fear grew in the gap between. This was not new. The history of comets is also a history of fear. Ancient chronicles describe them as omens of war and disaster, as fiery swords cutting across the heavens. Halley's comet was long feared as a herald of death. Even Hale-Bopp in 1997 carried tragedy, its brilliance interpreted by some as a sign of salvation and leading to desperate acts. The echoes of those fears resurfaced in 2025. People remembered the past and applied it to the present. The green and the grey were not just scientific anomalies, they were the latest broomstars, the latest signs, the latest sparks of unease. Science struggled to counter that fear. Press releases emphasised natural explanations, no matter how incomplete. Experts reminded the public that anomalies are not evidence of intelligence, that order can emerge from physics, that coincidences happen even when they look deliberate. Yet their words were drowned out by images that spoke louder. A photograph of arcs in a dust tail did more to fuel speculation than 1,000 words of technical caution could undo. A spectrum filled with peaks no one could identify spread faster online than any sober analysis. The collision between science and fear was not equal. Fear always moved faster. The collision was amplified by timing. Mars had become the centre of the geometry, the silent stage where both visitors passed. Humanity has long invested Mars with symbolism, the god of war, the planet of destiny, the world we dream of colonising. To see it framed between anomalies was to see symbolism handed to us on a cosmic scale. Science said coincidence. Fear said design. And fear had the stronger voice. Commentators spoke of Mars being under surveillance, of visitors converging to mark it, of messages aimed not at Earth, but at our neighbour. The suggestion that Mars was under watch, that it was seeing before us, added a layer of unease that science could not easily dismiss. The more instruments struggled, the worse the fear became. Each contradiction in the data was interpreted as confirmation of something unnatural. If mass estimates could not converge, perhaps the object was hollow. If dust filaments aligned, perhaps they were engineered. If colours shifted unpredictably, perhaps they were intentional signals. Science meant these contradictions as puzzles. Fear translated them into evidence. The collision was not about facts, it was about interpretation. Governments noticed. Public unease has consequences, and in the era of instant communication, narratives spread globally in hours. Agencies issued statements meant to calm, emphasising that neither visitor posed a threat to Earth, that their passes near Mars were distant and harmless. But the very need for reassurance fed suspicion. If they had to say it wasn't dangerous, maybe it was. If they had to deny intelligence, maybe they feared it. Science's voice, careful and measured, could not compete with fear's ability to fill silence with certainty. At the heart of the collision was uncertainty itself. Science thrives on uncertainty, treating it as the engine of progress, but fear despises it. When people are told that something cannot be explained, they supply explanations themselves. The green of Atlas, the grey of its companion, the geometries around Mars, all were canvases for projection. Some projected awe, seeing beauty in the unknown. Others projected fear, seeing warnings or threats. The collision was not just external, it happened within individuals, a clash of wonder and dread, of admiration and suspicion. The same images inspired fascination in some and sleepless nights in others. The scientists themselves were not immune. In private, many admitted their discomfort. Instruments are supposed to clarify, not confuse. Models are supposed to converge, not collapse. To see numbers refuse stability was unsettling even to the professionals. They did not jump to intent, but they felt the weight of anomaly pressing against their confidence. For them, the collision was internal, the discipline to maintain scientific caution against the human instinct to wonder if something more was happening. Some confessed that alone at night, staring at images of arcs and spectra, they felt the same chill as the public did. They knew the models should explain, they knew they didn't. Mars, as always, remained silent. Its thin sky glowed briefly with auroras, Its orbiters relayed terabytes of unexplained data. Its rovers recorded faint smudges of passing visitors. The planet offered no interpretation, no comfort, no meaning. It was only the stage. But in being the stage, it intensified the collision. If Earth alone had observed the anomalies, the story might have been smaller. With Mars at the centre, the symbolism multiplied. Science could not stop the interpretations. Fear could not be silenced. Both collided in the skies of a red planet that neither asked for nor acknowledged the role it had been given. As the visitors moved on, the collision did not end. Data continued to flow in, confusing as ever. Papers were written, theories proposed, conferences filled with cautious debate. At the same time, the public continued to interpret, to speculate, to fear. The green and the grey remained in memory not just as objects but as symbols of the collision itself. Science had recorded them. Fear had defined them. Together they became part of the same story. Not just visitors in the sky, but catalysts for a confrontation between what we know and what we fear we do not. And in that confrontation lay the deeper unease. If anomalies are natural, they remind us of the limits of knowledge. If they are not, they remind us that we may not be alone. Both possibilities are unsettling. Both feed fear in different ways. Science tries to choose the first. Fear often chooses the second. The collision between them is not a failure of either. It is the inevitable result of being human in a universe that refuses to explain itself quickly. Whenever the sky offers something that unsettles us, theories bloom. They do not wait for peer review, they do not need data to converge, and they do not vanish when scientists say inconclusive. They thrive in the very soil of uncertainty, spreading in all directions, some grounded, some speculative, some outlandish, but all unwilling to disappear. The autumn of 2025 became a season not only of anomalies, but of explanations that refused silence. As Atlas and its massive companion crossed near Mars, as instruments struggled to explain, the human urge to narrate filled the gap. Theories multiplied, collided, and lingered, becoming part of the story just as much as the visitors themselves. The first category of theories stayed close to science. They tried to fit anomalies into natural frameworks, to stretch known physics just far enough to account for what instruments had recorded. Some proposed that the larger visitor was not a single body, but a loose cluster of fragments bound weakly by gravity, a swarm masquerading as one. This would explain the contradictory mass estimates, the shifting brightness, and the chaotic spectra. But the images from Mars's orbiters showed a nucleus too coherent, too structured for a swarm. The theory lingered but didn't hold. Others suggested exotic ices. Hydrogen, nitrogen, or oxygen ices are rare but not impossible, and if present in unusual ratios they could explain the unpredictable emissions, the turquoise and violet flares. But these ices sublimate quickly, and the object's persistence argued against them. Models built on exotic chemistry produced results that matched a few nights of data, but failed across weeks. Again the theory faltered, but it did not vanish. Rotation-based theories gained traction. Perhaps the nucleus spun in a complex tumbling motion, exposing different surfaces with wildly different compositions. Each rotation would shift emissions, alter brightness, reconfigure dust jets. This could explain the apparent rhythm in the brightness pulses, the arcs of dust that seemed to repeat. But when radar attempts were made, they showed no simple tumbling. The object's spin was slow, steady, and inconsistent with the rapid variability observed. The theory explained some things but left too many untouched. Other scientific theories grew bolder. Some proposed internal heating, radioactive decay, or trapped energy, releasing pockets of gas in unpredictable bursts. Others invoked magnetized materials, iron-rich veins producing fields that shaped dust into arcs. Still others suggested gravitational interactions with unseen fragments, small companions that distorted observations without being detected. Each paper, each conference, added another possibility. None fully explained the contradictions, but in science, theories do not need to win quickly. They only need to persist until better data arrives, and so they remained, not silenced, but hovering, waiting. Outside of professional circles, theories spread differently. They did not wait for data. They leapt from images to conclusions, from impressions to certainty. The aligned dust filaments, the synchronized arcs, the convergence at Mars. These became evidence, not puzzles. Forums filled with speculation that the visitors were artificial, probes, or constructs sent deliberately. Some claimed Atlas was the messenger, the green signal, while the larger visitor was the carrier, the grey vessel. Theories spoke of surveillance, of warnings, of choreography meant to be seen. They had no equations, no calibration logs, but they had conviction. For many, conviction mattered more than caution. Government secrecy theories resurfaced quickly. Every reassurance that the visitors posed no danger was taken as evidence of danger. Every delay in releasing data from Mars orbiters was treated as proof that something was being hidden. Past events like Hale-Bopp in '97 had produced similar reactions, but this time the convergence of two anomalies gave the theories more fuel. If Mars was under watch, maybe Earth was next. If Mars had seen before us, maybe agencies already knew more than they admitted. Silence, even when technical, became suspect. Theories refused to stay quiet. Religious interpretations grew alongside scientific ones. Some saw Atlas's green glow as a sign of renewal, a cosmic messenger announcing change. The larger visitor's stormy grey presence was cast as judgment, a shadow across the heavens. Mars, long associated with war, became the battleground in these narratives, the place where messages were delivered before humanity understood them. Ancient texts were quoted, myths revived, metaphors stretched across data. Theories here were not about numbers, but about meaning, and meaning never yields to silence. The collision of science and fear fueled the persistence. Each time scientists said, "We do not know," theories outside science said, "We do." Each time anomalies refused explanation, interpretations filled the void. It was not dishonesty, it was instinct. Humans do not leave silence unfilled. We name, we narrate, we project. Theories became the vocabulary of that instinct. Even within science, some theories tiptoed toward speculation. A few researchers openly compared the larger visitor to Oumuamua, noting the shared trait of unexplained, non-gravitational acceleration. They avoided words like artificial, but the comparison lingered. Others suggested that the synchronized geometries around Mars hinted at resonance, a subtle choreography of orbital mechanics we had not yet understood. They emphasized natural explanations, but the language they used, structured, patterned, non-random, echoed what the public was already saying in different words. The gap between caution and speculation narrowed. What made the theories refuse silence was not just anomaly, but symbolism. The green and the grey, the convergence at Mars, the echoes of broom stars and Hale-Bopp. Each anomaly came wrapped in imagery too compelling to dismiss. People did not only want answers, they wanted meaning. Theories provided it, whether through equations or metaphors. They explained not only the data, but the unease it created. Mars, silent and indifferent, did nothing to confirm or deny. Its orbiters relayed data, its skies glowed briefly with auroras, its surface remained barren. But by being the stage, it forced theories into existence. Mars became the reason people asked why here, why now, why this geometry? Theories were not optional, they were inevitable. As the visitors moved on, the theories did not fade. Atlas dimmed into the dark, the larger companion curved away, but the explanations remained. Papers continued to circulate, conferences debated, forums speculated, myths revived. Theories that refused to stay quiet become part of history. They linger long after the events themselves, shaping how we remember, how we interpret, how we prepare for the next anomaly. In the end, the visitors left us with more than contradictions in data. They left us with narratives we could not silence. Theories scientific, theories speculative, theories fearful, theories hopeful. They spoke across the silence, filling the void that anomalies always create. Science may one day explain the green and the grey, the mass that defied models, the geometries that looked like intent. But even if it does, the theories born in the silence will not vanish. They will remain, echoes of how humans confront the unknown, refusing to be quiet even when explanations arrive. Astronomy insists on probability. Every orbit, every encounter, every alignment can be traced back to gravity, to forces indifferent to our interpretations. Comets sweep in because perturbations nudge them. Asteroids cross paths because of resonances with planets. Alignments happen because the solar system is a clock of enormous gears, and once in a while the teeth line up in ways that catch our eye. Chance is supposed to explain timing. But in October 2025, as Atlas and the larger visitor approached Mars within 9 days of one another, chance felt thinner than usual. The timing was too precise, too coincidental, too heavy with meaning. And so the question grew louder. What if timing isn't chance? From Earth, the geometry was clear. Atlas, on its hyperbolic escape, swept past Mars on October 3rd. The larger visitor, vast and chaotic, followed on October 12th. Their paths converged on the same planet, almost as if Mars had been chosen. 9 days apart, both framed the red world. The probabilities were low, but not impossible. Mathematically, coincidences do happen. Yet the impression was different. To the human eye, it looked deliberate, like an appointment kept across cosmic scales. Science responded by running simulations. Computers modelled millions of random trajectories, asking how often two objects might converge on the same planet within days. The answer was rare, but not impossible. Low probability events occur all the time if you wait long enough, but the rarity itself became fuel for speculation. If the odds were so low, why now? Why Mars? Why two anomalies together, both carrying features that resisted explanation? Numbers insisted on coincidence. Perception refused to believe it. Mars's symbolism made the timing heavier. For centuries it has been the planet most tied to human imagination. The god of war, the target of colonization, the mirror of our destiny. To see it framed between two presences was to see meaning even where numbers denied it. Timing was not just days on a calendar. It was placement in history, context in myth, weight in narrative. Science said coincidence. Fear said choreography. Wonder said design. Timing became more than numbers. It became a stage. Theories multiplied, as they always do when silence lingers. Some suggested that the two visitors were fragments of a parent body, split long ago and only now converging again. If true, the timing would not be coincidence but inevitability, the echo of a breakup event written into orbits. Others proposed gravitational shepherding, a hidden mass or resonance that drew both objects along paths that intersected at Mars. These theories tried to naturalize the timing, to remove design and leave only physics, but none explained the anomalies in chemistry, in mass, in geometry. Timing alone could be explained. Timing plus contradiction was harder. Outside science, the interpretations grew bolder. Atlas became the messenger, the green envoy, arriving first to announce. The larger visitor became the storm, the grey guardian, arriving second to confirm. The timing between them looked deliberate, like sequence rather than coincidence. Some spoke of a dialogue staged across Mars, a performance with an opening act and a finale. Others spoke of warning, of two signals delivered in rhythm, separated just enough to show order. The narratives were not scientific, but they spread quickly, because timing speaks a language humans understand instinctively. Even within scientific circles, the unease was real. The timing was not impossible, but it was unsettling. It forced researchers to confront the fragility of probability. Low odds are not zero, but when low odds occur, they feel loaded. The question lingered in private conversations, not in papers, but in quiet remarks. What if this really is not chance? What if we are seeing something staged, even if we cannot say by what or why? Scientists did not publish those thoughts, but they admitted them to one another in late-night meetings, staring at diagrams of orbits that looked too neat to ignore. Mars itself, silent as always, offered no answers. It saw Atlas first, painting auroras across its sky. It saw the larger visitor second, overwhelming instruments with plasma and dust. It stood at the centre of the timing, the stage on which the sequence unfolded. If timing was coincidence, Mars was the unlucky intersection. If timing was not, Mars was the chosen witness. Either way, the red planet was placed in a role it did not request, framed by presences it could not acknowledge. The collision of science and fear returned here. Science explained timing with probability. Fear explained timing with purpose. The gap between them grew wider with every photograph of aligned dust filaments, every spectrum filled with unexplained peaks, every graph showing mass estimates that refused stability. Science could not stop fear from interpreting, and fear could not erase science's equations. Both coexisted uneasily, each aware of the other but unable to reconcile. Timing sat between them, a fact that demanded explanation and refused silence. History reminded us that this was not new. In 1910, Halley's comet passed close to Earth, and the timing of its cyanogen-rich tail crossing terrified millions. In 1997, Hale-Bopp's timing coincided with cultural fears, leading to tragic interpretations. Timing has always mattered more than data. Timing has always been the bridge between observation and meaning. The echoes of those past events returned in 2025, reminding us that humans always see timing as loaded, never neutral. The difference this time was scale. 2 visitors, not 1. 2 anomalies, not 1. Mars at the centre, 9 days apart. The timing was sharper, the impression heavier, the unease stronger. As the visitors moved on, the question did not fade. If timing is coincidence, the story ends as anomaly. If timing is not, the story becomes something else. A message, a performance, a pattern meant to be seen. Science does not allow intent in celestial mechanics, but perception does. And perception, in the autumn skies of 2025, refused to stay silent. If Atlas had arrived alone, it would have been remembered. A small green traveller from another star whispering its strangeness as it passed quickly through our system. Its nickel without iron, its faint glow, its clean trajectory into interstellar space. It would have been studied for decades. The second interstellar object we had ever seen, an echo of Oumuamua, a rare chance to measure the chemistry of another sun. If the larger visitor had arrived alone, it would have dominated. Its massive scale, its mass contradictions, its sprawling tails filled with arcs and filaments, its colours that changed nightly. It would have been called the comet of a century, a puzzle that refused measurement, a storm of uncertainty overwhelming every model. Alone, each was extraordinary. Together they became inseparable. By converging near Mars within days of one another, by aligning in a geometry that probability said should not happen, they fused into one story. It was not the story scientists wanted. Scientists prefer separation, clarity, controlled conditions. 2 anomalies at once were not helpful. They were messy. Every data set became entangled with the other. Auroras on Mars could not easily be attributed to one or the other. Plasma disturbances overlapped. Public speculation blurred the visitors into a single narrative. Atlas and the larger companion became less 2 objects and more 2 parts of a whole. The green and the grey, the whisper and the roar, the messenger and the storm. Science tried to keep them apart. Memory did not. The one story they became was larger than either alone. It was not just about interstellar chemistry or mass that defied models. It was about timing, geometry, coincidence, and meaning. It was about Mars framed between two presences, a planet made into a stage. It was about instruments that failed to explain, about data that contradicted itself, about theories that refused silence. It was about the collision of science and fear, the echoes of ancient visitors, the unease of patterns that looked like intent. All of these threads wove together until Atlas and the larger visitor were inseparable in narrative. They had arrived together, and so they belonged together, one story, not two. The public embraced the fusion quickly. Media did not speak of Atlas and the larger companion separately. Headlines paired them constantly, the green and the grey, the two comets converging, the double anomaly. Forums treated them as characters in a drama, one announcing, one confirming, both converging on Mars. Theories depended on their pairing, messenger and guardian, signal and carrier, dialogue staged across the sky. Their individuality was erased in favour of the duet. When two anomalies arrive together, they stop being two. They become one mystery written in stereo. Scientists resisted but could not escape. Papers continued to treat them separately, but conferences inevitably compared them side by side. Spectra were juxtaposed, orbital diagrams laid over one another, auroral disturbances plotted in sequence. The temptation to link was unavoidable. Even when science denied connection, it analysed them together. Atlas's anomalies echoed Oumuamua. The larger visitor's anomalies broke comet models, but their convergence tied them. Data was kept separate. Meaning was not. The deeper reason they fused into one story was human perception. Humans understand in narratives, not in isolated facts. A single comet can be anomaly. Two converging is plot, and once plot exists, separation collapses. The timing near Mars was too precise, the geometry too sharp, the symbolism too heavy. The mind insists on unity. And so Atlas and the larger companion became not anomalies, but a dialogue. Not coincidences, but choreography. Even those who rejected intent could not help but see the unity. Two bodies, one story. Mars became the binding thread. Without Mars, perhaps Atlas and the larger visitor would have remained separate in memory. But Mars placed itself between them, the planet we watch most closely, the stage on which both anomalies unfolded. It became the reason their stories merged, the canvas against which their contrast was painted. Mars saw Atlas first, with its green auroras. Mars saw the larger visitor second, with its storm of plasma and dust. Mars connected them by timing and perspective. Mars made them one. The one story they became was also a reminder of limits. Instruments struggled, models failed, theories multiplied. Science explained some parts, but not all. Fear filled the silence with speculation. Wonder filled it with meaning. Together they revealed not only the anomalies of the visitors, but the fragility of our explanations. When two anomalies converged, they did not just break models, they broke the illusion of certainty. They showed us that the universe can present puzzles that resist separation, resist silence, resist resolution. As they faded, Atlas dimming into interstellar dark, the larger visitor sprawling away in its contradictions, the story remained. Not two separate trails, but one shared narrative. The memory was not of a green comet and a grey one, but of the green and the grey together. Not of a messenger and a storm apart, but of a dialogue staged at Mars. Not of data and theory kept separate, but of a single season, when anomalies converged into something larger than themselves. History will remember them this way, just as Halley is remembered not for its chemistry, but for its recurring presence. Just as Hale-Bopp is remembered not for its dust composition, but for its brilliance. Atlas and its companion will be remembered not for their individual properties, but for their pairing. The one story they became is the story of convergence, of coincidence that felt like intent, of a red planet caught between presences. It will be told not as two visitors, but as one narrative written across the autumn skies of 2025. And in that memory lies the true anomaly. Objects pass by all the time, strange and ordinary alike, but rarely do they merge in meaning. Rarely do two become one story. When they do, they remind us that science is not only about data, and fear is not only about speculation. Both are about narrative, about the way humans make sense of the sky. Atlas and the larger visitor gave us anomalies. Together, they gave us a story that will not be separated.